So with that in mind, we're going to start off with Unit 1 here, equation solving. So if you would go ahead and get out these notes. We'll work through these notes. We'll do a break at 6:50. We'll do a 10-minute break then, and then we'll come back. So the first type of equation that we're going to encounter is a rational equation, and it could have variables in the denominator. Well, it could also have them in the numerator, but we're not worried. I'm not worried so much about that. So first thing you need to do is you may need to factor in order to find any least common denominators. If, like for that first one, you won't need to factor. And once you identify the least common denominator, you'll be able to multiply both sides by it. In other words, the numerators, multiply the numerators by it, and be able to work the problem. And the other thing is we're going to discuss excluded values. All right, so FYI, if you ever need a graphing calculator, I have a class set up here. So, all right, so for this first one, what would the LCD of this need to be? What do you think? X is going to be a part of it. 5 is going to be a part of it, but it's what power of X? What's the largest power of X amongst the whole thing? To the second. So now what that's going to enable us to do here is we're going to multiply both sides out by this LCD. So, judging by the old saying, what you do to one side, you have to do to the other. Now, I'm only going to demonstrate this, like this detailed once. So, when you multiply both sides by, what you do to one side, you have to do to the other. That's definitely a given. So basically, these 5x squareds are technically over 1. And if you remember from fractions, basically we would just be multiplying all of our denominators by 5x squared. So we would have 5x squared over x squared equal to 5x squared over 5x minus 5x squared over 5x squared. Now, what happens here is the purpose of getting an LCD and everything, multiplying all the numerators out by it, you're going to be able to get rid of all fractions when it's said and done. So, 5x squared over x squared, what is that going to simplify to? Just 5 over 1, or simply 5. Excellent. Equal to, well, what's 5x squared over 5x going to simplify off to? Just x. And 5x squared over 5x squared, what will that become? They do cancel out. We're dividing the same thing out. So basically, this is just going to become 1. Now, you have a very simple linear equation to solve. You look confused. You okay? No. All right. Again, if you're confused about something, please let me know. I will not be offended. Now, surely you can solve this. And you're supposed to say, yes, I can, but don't call me Shirley. X equals 6. Now, x equals 6 is a solution. It works. Now, one thing I want to do here is we need to identify any exclusions. Basically, are there any values of x that make a denominator equal to 0? There's only one. What do you think? What do you think x could not be? Correct. Basically, from the LCD, we can basically set the LCD not equal to 0. X cannot equal 0. And that's all, whenever you solve a problem like this, whether it's on a test or on a problem set, you'll have the solution. It will only be one value of x and list any exclusions. And you'll see similar questions on your MyLab. Now for this next one, you want to factor the x squared minus 4x. And anytime you get a problem like this, when you factor, the factors are going to be related. And we'll see that in just a second. So what is x squared minus 4x factored into? Close. You're thinking x squared minus 4. All I can do is factor x out of this. And it would just be x times x minus 4. Now, not only, x minus 4 is part of this denominator here, we've also now identified the what? We've identified our LCD. So we're going to go ahead and multiply all numerators by it. I'm not going to, demonstrate all the steps here, multiplying both sides by x times x minus 4. Instead, and I'm going to write this in factored form. So we'll multiply all numerators by this. X and x minus 4, x minus 4, x and x minus 4. So we go ahead and eliminate anything or cancel out. It's interesting. Way back when I was a practicum student for student teaching, like pre-service teaching, I worked with a teacher that hated to use the word cancel. But yeah, x minus 4s go, x and x minus 4 here, and the same thing here. So we'll have 4x plus, what do we have left here? Just a 1. And what do we have on the other side? Just a 6. Solve that equation. That's an easy one. So 4x equals 5, x equals 5 over 4, or 1 1/4. I would be more than happy to have it left as 5/4. Now, for this one, we're going to have not one, but two restrictions. Because x times x minus 4 cannot equal 0. So we're going to get two restrictions. We're going to get two values. One is x cannot equal 0, and the other is x minus 4 cannot equal 0, so that x cannot equal what? X cannot equal what? Well, 0 is one of them. What's the other restriction? 4, right. Very good. Now for this last one, these are the type of rational equations I really like to get. Now, if you notice, you do have two binomials, like x minus 7 and x plus 3, and you have a quadratic. In my world, this would factor into this times this. Otherwise, the equation's going to be jumbled, and it won't work. So I'm going to let you putz with this for a second. All right, so what do you reckon x squared minus 4x minus 21 is going to factor into? Correct. So what is that going to make our LCD? Our LCD is going to be what? X minus 7, x plus 3, yes. So you're going to multiply all numerators by this. Make the necessary cancellations or offsettings. It's interesting, like, any of you into pro wrestling by chance? Like, ever heard of Bruno Sammartino, wrestler? I guess it's a Pittsburgh thing, but his nephew was that teacher I worked with. All right, so the x minus 7s go away, leaving us with this. Basically, both factors go away. And we are left with this. And we have a very simple equation to solve at this point in time. We do that and we're good. So we can subtract x from both sides. And 4x plus 15 equals -1. We'll take away the 15. Sometimes I'll show, like, the steps. Sometimes I don't. And if you have a question about how I got something, please tell me. So we got x equal to -4 here for the solution. However, we are going to have some restrictions. What are the restrictions? X cannot equal 7. X cannot equal -3. And that's it. All there is to it. All right, so any questions on rational equation solving? All right, let's move on then. We're going to now move on to absolute value equations. Now, I like to think of absolute value two different ways. Well, they basically do mean the same thing. One way to think of it is the value of a number without its sign, and the other, more technical mathematical definition, is how far from 0 is it. So, for instance, the absolute value of 3 is going to be 3. The absolute value of -3 would be 3. Now, while that is a true technical definition, let me kind of give you a graphical or a little more visual depiction on why that is. So here's 0. Actually, I'm going to change this. I'm going to do this one in blue. So here's +3 and -3. Now, thing is, the distance between -3 and 0, how far apart are they? Just 3. That's right. How about 0 and 3? They're 3 apart as well. So, the absolute value of x and the absolute value of -x are both going to equal x. So, another safe thing to say, absolute value equations are going to have 2 solutions, as opposed to a standard linear equation with only 1 solution. So, this, again, might seem really easy. A nice basic one, absolute value of x equaling 7. What values of x would satisfy that? Yep. I always forget to do this. Do this thing where Hearing recognition. Do this. Start it. That's cleaning up. All right, so x will equal -7 or x will equal +7. Now, I'm not going to make you do this each and every time, but it's just to show you that another way to show you that there are in fact two solutions to this. Now, how about absolute value of x equaling 5? Well, x will equal, yep, 5, or x will equal -5. Now, I'm going to throw in a little curveball here. Absolute value of x minus 2 is going to equal 6. There will be two solutions. Now, there is one very obvious one, and you're probably going to tell me that it's 8. Now, there will be a second solution. Now, you might have to kind of think about that or something. Anyone have the other solution? Give you a hint. It's going to be negative. -4 is right. Very good. Now, here is the really neat thing here. What is the midpoint between these two? The halfway point. Not 0. Halfway between -4 and +8. It's going to be 2. The distance between here is 6. So this other side basically is distance. And, x minus 2, you would think that should be x plus 2. But in the next unit, we're actually going to understand a little more why that really is. But here's the thing. X minus 2 will equal +6. X minus 2 will also equal -6. Basically, the other side changes. We take the opposite. Now, in other words, whatever's in that absolute value is never going to change. So x will equal 8, x will equal -4. So now, again, I'm using these notes back when I taught algebra. I used a version of these when I taught Algebra 2. So let's say this. Let's say at a hotel, rooms are numbered 1 through 50. Let's say you get assigned to room 15. You find out your significant other is 5 rooms away. So what rooms could they be? 10 or 20, very good. So what happens here, 15 is obviously in the middle, and they could be in 10 or 20. So this would be x minus 15 equal to 5. I'm not going to make you write out an equation here, but we are actually going to come back to this concept in the next unit when we get into transformations. But the main idea here is to obviously solve absolute value equations. So, when solving, you have to keep whatever was inside the absolute value as it originally was. And a lot of students that I've taught in the past would solve by doing x plus 4 equal to 9 and x minus 4 equal to 9. Thing is, the other side is the only thing that changes. So basically, you get 2x minus 3 equal to 5, or 2x minus 3 equal to what? Negative 5. So whatever was in that absolute value is never, ever going to change. So we solve them. 2x equals 8, x equals 4. 2x equals negative x equals negative 1. So I'm going to let you try that next one. Now, one of the answers will have a fraction. Just leave it as a fraction. So we are going to get two equations out of this. 3x minus 7 equals positive 11, or 3x minus 7 equals negative 11. So in this case, 3x equals 18, x will equal 6, 3x will equal negative 4, x will be negative 4/3. So whenever you encounter one of these on either MyLab or on a test or on a problem set, don't convert them to decimals or try to deal with mixed numbers. Just leave it like that. That's all you need to do. And another thing I want to show you, I'm going to show you kind of using my calculator that, yeah, I mean, this does work. So yeah, if I ask it to solve this, first. And the equation was absolute value of, I believe it was 3x minus 7 equals 11. And there you have it. All right, so that's going to take us into our next question. What if we encounter an equation such as this? Now, basically, in other words, you have to treat the absolute value as a variable and get the absolute value by itself before you actually solve it. So you have to subtract 9 from both sides and then divide out by 3. Another thing is, with my equations, the way I'm going to write my equations, the absolute value, whenever you're taking a test or on a problem set of mine, the absolute value by itself will always equal a whole number. So if for some reason you didn't get it equal to a whole number on paper, you're wrong. So check it. So then you have x minus 3 absolute value equal to 1. So you have x minus 3 equal to 1, or x minus 3 equal to negative 1. X will equal 4, or x will equal 2. So yeah, you can solve this. Yeah, 3 times the absolute value of x minus 3 plus 9 equals 12. And you get 2 or 4. Now, you never distribute across an absolute value. That's just totally incorrect. So the next thing here, I've had some teachers would actually replace the absolute value with maybe a symbol, like a smiley face. I've seen girls do it with hearts. Some more hardcore math teachers would replace it with a different variable, maybe a U. And they get that from the fact that when you take calculus, you'll be doing what are called U substitutions. So symbolically, we replace the smiley face with x absolute value of x minus 3, and we get the smiley face equal to 1. And then we solve. So basically, that's what so you can do it that way, or you can do it the conventional way. So we're going to work on a couple of these. Let's work on this first one. We have 2 times the absolute value of 5x minus 9 plus 4 equal to 6. So you can either take the conventional approach and treat that absolute value like a variable, or you can do a substitution. Maybe a triangle. Absolute value of 5x minus 9 equals triangle. So twice the triangle plus 4 equals 6. Now again, the absolute value will always be equal to a whole number. So the absolute value of 5x minus 9 is going to equal 1. You're then going to get 2 equations to solve out of that. So you'll have 5x minus 9 equal to positive 1, or what's the other equation going to be? Correct. And again, only the other side is going to change. And then you're going to solve it and go from there. I teach an online class, fully online class this semester for the first time in my career. And I'm getting the students, sending their assignments, and whenever they send them, I get an alert. It's kind of cool. 5x equals 10, x equals 2. 5x will equal 8, x will equal 8/5. All right, now, this thing, desktop activator, I don't. So, what do you think is the wrong thing that many students would do with this problem and the next two? They would subtract 5 minus 6. Why can't you do that? Correct. Now, here's the thing. I love these types of absolute value equations and inequalities. These are the ones that you're going to see on a test or on a problem set. Those are the ones. So what would the first step be if I were going to take the conventional route? What would I need to do first? I could, let's substitute. Let's call it u. Absolute value of 2x minus 3. 5 minus 6u equals negative 61. Now, what can I do? Let's take away the 5 from both sides. We get negative 6u equal to negative 66. And then, what happens? We divide by negative 6. So u is going to equal 11. So absolute value of 2x minus 3 will equal 11. So 2x minus 3 will equal 11. 2x minus 3 will also equal negative 11. And we solve it. And again, yeah, that is a very rookie mistake that people tend to make. So let's see, 2x is going to be 14, x is going to be 7, 2x will be negative 8, x will be negative 4. Okay, I'm going to let you try those next two. And again, yeah, the absolute value equation or inequality that's on a problem set or test will be just like one of these. These are fun. Okay, so yeah, in either event, you're going to substitute first. So I'll let u equal the absolute value of 10x plus 8. So we'll have 5 minus 10u equal to negative 115. We take away 5, negative 10u equal to negative 120, u will equal 12. So the absolute value of 10x plus 8 will equal 12. 10x plus 8 will equal positive 12. 10x plus 8 will equal negative 12. And we solve both. Get an answer and call it a day. So let's see here. 10x equals 4, x equals 4/10, but that simplifies to 2/5. 10x will equal negative 20, x will equal negative 2. All right. We good on that one? Any questions? Again, yeah. Questions, I will help you. All right. So we're going to let u be the absolute value of 4x plus 5. So we'll add 10 to both sides. Negative 2u equal negative 46. U will equal 23. Four x plus 5 will equal positive 23 or negative 23. 4x will equal 18. X will be 18 fourths or 9 halves. 4x will equal negative 28. X will equal negative 7. All right. Going to give you a minute, give you a little bit on that last one here. So I just saw that North Carolina State has gone virtual. All right. Anyone have some solutions to these? Negative 3 and positive 13? No, you are incorrect. And you're probably baffled. Wait, let me check my work. Your work is right, but here's the thing. What's the absolute value of negative 5? Can an absolute value ever equal a negative number? Trick. I threw a trick here. There's no solution. Absolute value must always be positive. And when we do the transformation unit in the next transformation, see, units 1 and 2 are so easily combined. And same with 3 and 4. I was actually able to shave some time off, with combining. But we're going to see that from a graphical approach, why that works, why that's the case in the next unit, in the next few weeks. But for now, we'll just, if the absolute value by itself is negative, there's no solution. Now, I will not ask you those on a test. You might see them on my lab math. So that is going to put us to an end for absolute value equations. We're now going to move on to solving quadratics. Now, our first day of class involved factoring quadratic equations. We're going to learn how to solve those today. So, we'll also be able to connect those graphically, more so in the second unit, but we'll see that. So let's say I do a long chain of multiplication. What's that product going to be? It would be 0. Basically, that's going to lead us to the zero product property. In other words, for any real numbers A and B, if A times B is equal to 0, then either A is 0 or B is 0, or they're both 0. So in other words, what happens here is if you have a set of factors, a product of factors that equals 0, this can work for an infinitesimal amount. We're only going to go as far as 2 in the first unit. Now, in the first 2 units, in units 3 and 4, we'll go up to 4 factors, but it'll be pretty easy. So, how does the zero product property work in solving equations? So basically, this product is equal to 0. So 2x plus 1 times x plus 3 equals 0. Basically, you set each of those factors equal to 0 and solve. So, 2x equals -1, x is -1/2. X will equal -3. Now, one thing that you might see are an ordered pair like in braces. That implies solution set. Now, that's okay, but not this, because if they're surrounded by parentheses, this is supposed to imply that's an ordered pair. That will not work. So that's how that's going to work. All right, so the other side equals 0 here. So what we're going to do is we're going to factor this quadratic. So this quadratic will factor into what? Because it's only x's here, we don't need to do the whole factor by grouping. Remember, the sum is -7, and the product is +12. -3 and -4 are the numbers. So basically, x minus 3 and x minus 4. So x minus 3 equals 0. X minus 4 equals 0. So x will be 3. X will be 4. Which these are inverses, additive inverses of the two numbers. That's not a coincidence. That's how it's going to work. Turn the recorder back on. Yeah, again, if you feel like playing me back, I mean, there are some people, I'll tell you, there are a lot of teachers that say that they don't want to be recorded, you know, but I'm an open book. I'm not hiding nothing here. You know. All right, so let's try that next one. X squared minus 6x plus 5 equal to 0. Let's do it. The words of Gary Gilmore. That was his last words before being executed by the state of Utah. You know, whenever they are about to put you to death, they say, "Do you have any last words?" His word, let's do it. It's a way to go. So, yeah, I can write out this, like our desired sum is -6, and our product is +5. What are the two numbers? -5 and -1. X minus 5, x minus 1 equal to 0. So we get x minus 5 equal to 0, or x minus 1 equal to 0. X equals 5, or x equals 1. Now, there are apps that are on the graphing calculator that would actually solve this for you. I mean, they won't show you the work, but they will solve it for you. All right, and give me a minute on that next one. This one you would have to do factor by grouping. So our desired sum for this one is -6. Our desired product is +9. So what are my two numbers going to be? Correct. -3 and -3. If it happens twice, so be it. This is where you get to do factor by grouping. But you're going to find something interesting about this in just a second. Oh, you work at PTs. Oh, I love PTs. So I can take a 3x out, and so I get 3x minus 1 here. I can take out a -1. So 3x minus 1 times itself equals 0. Now you're probably thinking, wait, I thought quadratic equations were supposed to have two solutions. Well, it is the same solution. Technically, well, let's figure out what the solution is first. 3x equals 1, x is 1/3. But the technical term is it occurs twice. But we are going to see how all that works. We're going to see a little bit more about that in upcoming questions. All right. Any questions on this one, ladies, gentlemen? All right. Slight hint for these, try factoring something out, a number, first. So what could I factor out of this? I could factor a 2 out. And theoretically, I could just divide both sides by the 2. But now I get x squared minus 3x minus 10 equal to 0. So I can factor this sucker into what? Negative x minus 5 and x plus 2 equal to 0. So x minus 5 equal to 0, x plus 2 equal to 0. X will equal 5, or x will equal negative 2. All right, give the next one a whirl. Now, one thing is, some of you may have gotten an alert through VSO that you didn't register for your MyLab or do your Moodle quiz. If that's finished, I'm gonna close out the alert. That was just to kind of let you know, hey, do that. So I think I'm going to take a negative 3 out of this. So you are going to need to find two numbers that have a sum of -2 and a product of -15. So what are my magic numbers? -5 and +3. It seems right here. And then we get to factor by grouping. Take an X out of this and just a 1 out of this. So we get our solutions of 5/3 or -1. Now, before we go on to the next one, I do want to show you something on the graphing calculator. So if you go into apps, I don't want the key press this. So under polynomial simul 2, polynomial root finder, this has a degree of 2 or order of 2. I'm going to enter the coefficients. You know, I could have done 3x squared minus 2x minus 5, but the other side must be equal to 0. So -9. Now you could change the sign. I hate doing that. +6. I'm just going to bypass that. 15. Hit solve. Look at that. Neat little way to help out. All right, so what if one side of the equation is not equal to 0? Well, guess what? We got to make it happen. So I can do this in one shot. You know, I could take away 3x and 21 from both sides, which ultimately gives me 6x squared plus 11x minus 10 equal to 0. Then you get to solve it. So I need to find two numbers that have a sum of 11 and a product of -60. What are they? 15 and -4. Then you factor by grouping and go through that. So we get 2x plus 5 and 3x minus 2 equaling 0. 2x plus 5 equals 0. 3x minus 2 equals 0. X is negative 5 halves. X is 2/3. All right, I'm going to let you try that next one on your own. Remember, you got to get everything over to one side. Whoop. All right, so I got to bring everything over to one side. So I'll take away 4x squared, add 3x, and add 10. So I'll get 6x squared minus x minus 40 equal to 0. Ooh, this could be a little entertaining here. Two numbers have to have a sum of -1, but what's our required product? Negative 240. Ooh. Okay, what are they? 15 and negative 16, yep. On a test, I don't think I would give you one with a huge product like that. No, I wouldn't. On a problem set, yeah, but on a test, no. So then we just have to do some greatest common factoring. Take a 3x out. That would be 2x plus 5. And I can take a 4 out, and that's 4x plus 10. Wait, I don't have the same thing in the parentheses. What did I do wrong? What's that? Oh, I should have, that wasn't the greatest common. I actually did that on purpose. So, we got to take out a -8 instead. Just had to keep you on your toes. So 2x will equal negative 5. X will be negative 5 halves. 3x will equal 8. X will equal 8 thirds. All right. Not bad. How do we feel about factoring here, folks? Feeling good? All right. All right, give you a moment or two to catch up. All right, so we can also solve quadratic equations using the square root property, simply by getting the variable part alone and taking the square root of both sides. So rather than expanding that out and factoring, what we're going to do is we're going to leave that x minus 2 as x minus 2 squared. So for this first one, what can I do to both sides? We'll add 24. So we'll get 3x squared equal to 24. Then we're going to divide both sides by. Now, that means x squared will equal 8. Now, we have to take the square root of both sides. Now, what happens here, let me give you a short mathematical explanation. The square root of x squared technically becomes the absolute value of x. But what then happens is it'll just become plus or minus the square root of 8. I'm not going to show this intermediate step, but this is why whenever you have something squared, the other side will be plus minus. So, let's break apart the square root of 8. Break that into simplest radical form. We didn't go over it in class, but there's a video on how to do it. Square root of 8. What is the square root of 8? Well, we could just, we know that 8 is 2 times 2 times 2. So square root of 8 is root 2, root 2, root 2. Now, how many of the same thing do we need to get a whole number out of it if we're dealing with square roots? 2. If we were dealing with cube roots, we would need 3. But we're not dealing with cube roots. We're only dealing with square roots. So these two go to the dance together. That one stays alone. So it'll just be 2 root 2. X will equal plus or minus 2 root 2. All right. Try that one. So we'll add 12 to both sides of this. And then we'll divide by 2. And then we'll take the square root of both sides. So we'll have x minus 2 equal to plus or minus the square root of 24. Let's break apart that 24. Now, if you can do it without actually having to break it up into individual factors and whatnot, good. If you need to, that's fine too. So 24, two numbers that multiply to it are 2 and 12. That 2 is prime, so I'm going to circle it. Let's see, we get 2 and 6, then 2 and 3. So basically, 24 is 2 times 2 times 2 times 3. Root 24 is root 2, root 2, root 2, root 3. So we have two of the same thing here, but what happens to this? We combine that into a 6. So x minus 2 will equal plus or minus 2 root 6. We'll move this 2 over, and we're actually going to get into this concept probably not today, when we may or may not, but yeah, we'll see. Well, probably won't. We'll get to the basics of completing a square. But this is the idea. This is like one of the later steps in solving an equation when you complete the square. I have some more time budgeted, so we're in good shape. All right. So for those three, I want you to factor those. You're going to notice a pattern with this. So what will this first one factor into? X plus 4 quantity squared. All right, someone else. How about this next one? X plus 3 quantity squared. How about this last one? X minus 5 quantity squared. These are all perfect square trinomials. Trinomial means it's 3. And they factor basically into x plus or minus c. So the nice thing is, yeah, when these factor, you're going to already kind of know how they factor. when we actually make one side a perfect square. You have to ask yourself now, what will complete the square? So x squared plus 2x. So here's the thing. On this side is an x plus 1. On the vertical is an x plus 1. Now, how many single number cubes would complete this? Little small cubes, how many would do that? Just one. So basically, this is x plus 1 quantity squared equaling x squared plus 2x plus 1. Now, what's on the horizontal and vertical for this one? X plus 2. Now, that would be x squared plus 4x, but how many little cubes would complete the square on that one? 4 would. Now, so we know x squared plus 2x plus 1 was in fact x plus 1 quantity squared. We know x squared plus 4x plus 4 was in fact x plus 2 quantity squared. Now notice that this middle term is all even numbers. So x squared plus 6x. Now just imagine, an extra bar, here and here, if you will. How many do you think would complete the square on that one? Yeah, 9 would. And this would be x plus 3 quantity squared. How about if it was 8 of those? Not quite. 16. One thing you're probably noticing is, x plus, this is all going up by 1 each case. So x squared plus 10x, what would complete the square for that one? 25. How about 12x? 36. 14x. And 16x. Now, all of these numbers are perfect squares. Now, here's the big question I want to ask you. Let's say I didn't actually put, x plus 6 quantity squared or whatever. How could I have gotten that last term? Think about that for a minute. Like going from, 2, take half of it, that's part of it. So the half is here, but then what do? Multiply it by itself, which means square it. You take half the middle term, square it, and then add it to both sides. Well, yeah. Now, what if the sign before the linear term is negative? So this would become x minus, well, what's half? Oh, I just gave it away. What is half of negative 2? Negative 1. But what happens when we square it? It's positive. Becomes positive. So even if it's a negative or a positive before that middle term, it's going to be a positive in the end. So we plus 4, so x minus 2 quantity squared, x minus 3 quantity squared, then x minus 4 quantity squared. The purpose of completing the square is it's going to enable us to solve quadratic equations that might not otherwise be factorable. We're going to look at some easy ones by completing the square. However, we'll look at radicals and imaginary numbers later on. Radicals will be a little bit later on Tuesday. Imaginary numbers are in Unit 3. Basically, what happens is when we complete the square, we make one side of the equation a perfect square trinomial. So when we've converted one side to a perfect square trinomial, we can factor it without thinking, without having to think. Like, okay, what goes into this and that? No, we don't even have to think. It's boom, automatic. So we're going to start off with a nice, easy one. First off, I want you to solve this one by factor. Whoops. So we would have x, what would this factor into? X minus 6 and x minus 4. So basically, we set each of those equal to 0. X will equal to 6, or x will equal to 4. Now, I'm going to walk you through on how this would be solved using the completing the square method. So we've already solved this one. Now, it goes to show that quadratic equations can be solved in multiple ways. So if we want to complete the square, and don't worry, we're going to walk through another one of these. So we're only going to leave whatever's in front of the x squared. That will only have a 1 for the view from, well, today, definitely. So we need to move the constant over to the other side. Now, if there was something in front of the x squared, we would divide out. So we take half of the linear term squared and add it to both sides. Half of negative 10 is negative 5. That squared is 25. So that's what you're going to be adding to both sides. Now, this left-hand side, you'll be able to factor that lickety split. Boom, be done. And then you would take the square root of each side, and you would have x minus 5 equal to plus or minus 1. And then you solve them and you get 6 and 4. All right. We're going to walk through this next one together. Actually, these first two we'll walk through together. Let's see it. All right, so what would the first step need to be? We're going to add 24 to both sides. Now, I am going to leave a spot here. Now, half of -2 is what? Half of -2 is -1. -1 squared is +1. So what are you going to end up adding to both sides? 1. So this side becomes 25. Now, this will automatically factor into what? X minus what? 1. That's it. This one's going to be a little more involved because it can have a decimal or a fraction. But we can then take the square root of both sides. Basically, we would have x minus 1 equal to plus or minus 5. Now, we could just add the 1 and do 1 plus or minus 5, or solve them individually. You know, we have 6 and -4. Or, you know, x minus 1 equal to +5, x minus 1 equal to -5. X equals 6, x equals -4. You can represent it either way, doesn't matter to me. Pretty cool, huh? All right, so for this next one, we need, what's our first step going to be? We're going to add 24 to both sides. So we'll have x squared plus 5x equal to 24. Now, we can do this representatively with either fractions or decimals. The decimals will terminate at this point. So now, we have to ask ourselves, what do we need to add to both sides? Well, 1/2 of 5 is 5/2, or 2.5. But what would we have to do with that 2.5? Square. So 5/2 squared would be 25/4, or 2.5 squared would be 6.25. So this could be done using either fractions or decimals. However, there will be a case where, like, if the leading term was a 3, you'd have to use fractions. So yeah, x squared plus 5x, let's do it with the decimals. 6.25 equal to 24 plus 6 1/4. So this becomes x plus or minus plus, and this will be 30.25. X plus what? 2.5. Because, yeah, you might be thinking, oh my God, we never factored ones like this. It's either half of the middle term or the square root of that. Boom! That's how it works. So we then get to take the square root of both sides. So x plus 2.5 equals, well, let's see. Just get out of there. Square root of 30 1/4, 30.25 is 5.5. Oh, I forgot. Plus or minus 5.5. So basically, x plus 2.5 equals 5.5, or x plus 2.5 equals negative 5.5. And then you solve them individually. X equals 3, or x equals negative 8. Now, it's true. You could have probably factored that one easier. But I'm just trying to show you, completing the square does work. Now, I'm going to sort of restart the problem here. Get x squared plus 5x plus 25/4 equals 24 plus 25/4. Now, we know this would be x plus 5/2 if you did it with fractions. Now, if you did 24 plus 25/4, here's something kind of cool. 24 plus, if you hit alpha and y equals, you get n over d, an automatic fraction. You get 121/4. I wouldn't ask you to do that like by hand or something. So x plus 5/2 equals plus or minus 11/2. And you would get 6/2 or negative 16/2. Same thing as above. All right, so this is where we're going to have to stop today, because I just won't have enough time to get off the next step here. We're going to pick up right where it's left off. I know Tuesday, September 1st, that's a week from this coming Tuesday, that's when the next lab is due. Your first lab is due this coming Tuesday. So, all right, everyone. I hope you all have. All right, so we're going to do some more completing the square. So in either event, you've got to move the constant over. Let me see it. So you're going to move the constant over. So in that case, you're going to do what to both sides? We're going to add 7. Sorry, ladies. We're going to subtract 7 from both sides. We're going to move that 7 over to the other side. So now we have to figure out, what are we going to add to both sides? Well, if you remember, what you need to add to both sides, well, first off, I already know what it is, but how do we figure it out? What do we do? Correct. And why did we do it to the negative 10? Why didn't I do it to the 7? No, it's because it's the linear or middle term. So what is it that I'm going to be adding, well, you are going to be adding to both sides? 25 is right. Excellent. So this automatically factors into what quantity squared? What squared? X minus 5. So we're going to have x minus 5, and that is going to equal to 18. Oh, sorry. I'm going to trip over these desks one day. Wouldn't be the first time I've done it. Oh, I could write a book on my teaching career. So then we got to take the square root of both sides. Well, we have this square root of 18. Now, that, unlike any other number, that is not going to simplify into a nice, clean number. So, what we have to do is break it apart. So, I do know that 18 is 2 times 3 times 3. So it'll follow that square root of 18 is root 2, root 3, and root 3. And how many of the same square root do I need to get a whole number out of it? 2. So I now get 3 root 2. So we get x minus 5 equal to plus or minus 3 root 2. Now, we can just add this 5 over, or you could do it separately, but basically it would be 5 plus or minus 3 root 2. You have 5 plus 3 root 2, and 5 minus 3 root 2. Now, one of the terms, these are known as, actually as conjugates of each other. Basically, the only difference is the sign between those two. That's all. So that's how that is going to work. All right, I'm going to let you try that next one. All right, so let's go to this next one here. Sure, what's up? Okay, what is half of negative 10? What's negative 5 squared? That's working. It's all right. Don't worry. That's why you ask questions. You're all good. All right, so we're going to move that 16 over. Now, you're going to find something rather quirky about this. Don't freak out. All right, so what are we going to be adding to both sides of this? Adding 16. Why 16? Well, half of negative 8 is negative 4, and negative 4 squared is 16. So basically, yeah, we're left with the same daggone thing as before. So you might freak out over this and say, like, oh man, did I make a mistake? The answer is no. I'll take that. Yeah, like now at the break, anytime I'm collecting labs, they'll go right up here. And you'll find the keys on Moodle. All right, so this is going to factor into x minus 4 quantity squared equaling 0. Now, here's the thing. Yeah, we didn't actually have to go through all that business of completing the square because it takes us right back to where we started. But we have x minus 4 equal to plus or minus 0. Well, plus or minus 0, no matter what, is simply what? Simply 0. So, x minus 4 equals 0. X is going to equal 4, but how many times does that solution technically occur? Twice. That is the technical term. It occurs twice. All right. Now, yeah, this can be factored. Well, we already demonstrated that, yeah, that is factorable. This one cannot be factored over the integers. That's going to come into play a little later on today. Now, what if you have something other than a 1 in front? Well, what you have to do in this case is divide all terms out by it and then complete the square. And you're probably going to need to apply use of fractions. Don't freak out. That's why we have Mr. Calculator. So for this one, what do I need to do to start us off? Let's divide every single thing by 2. So we now have x squared plus 9/2 x equal to, fortunately for us, the other side is a nice clean number, 28. Now, we have to figure out what are we going to add to both sides. Well, here's how we figure that out. What is half of 9/2? Remember, when you multiply two fractions, you multiply the numerators and denominators. So for that, it is going to be 9/4. But what do we do with that 9/4? Square it. And that will be I'm hearing mumbling like it will be, oh wait, I want to do it this way. Alpha y equals sets up that fraction. And it's 81/16. So that is what we are going to add to both sides. So x squared plus 9/2 x equals 28. But to both sides of that, we are going to add 81/16. Now, how is this left side going to factor? See, I always have to pace when I teach. I just cannot stand in one place. That's been my life story for 38 years. Well, no, I wasn't teaching at age 0, but anyhow, what's this left side going to factor into? Well, we know it's going to be x plus something. I'll give you a hint. We calculated that. It has something, 81/16. This is going to factor into a perfect square. You'd have to take the square root of this. Well, hey, we already know that, don't we? What is it? 9/4. Boom! And we now have the 28 plus the 81/16. And you can use your calculator to figure that out. I'm not going to make you show me how you do that with everything. So, I'll just add 28 to this, and we get 529/16. Get the calculators, that's why they're there. Now we need to take the square root of both sides. Oh, I always forget to do this stupid thing. Then oh, there we go. That makes it a lot better. The dang search box is in my way. All right, so we're going to have x plus 9/4 equal to plus or minus 529/16. And that's going to be 23/4. So we can set that up as two individual equations, or we could just subtract 9/4. So x would be negative 9/4 plus or minus 23/4. So negative 9 plus 23 is what? Positive 12. Is that? Yeah. 14. So also the denominators are magically going to end up being the same. So we'll get 14/4 or 7/2. And negative 9 minus 23, that would be negative 32/4 or negative 8. 7/2 or negative 8. Those are your solutions. All right. So for this last one, I've got a couple of things to do. How can I get that started? Let's divide out everything by 3. And sucky thing is it's going to leave fractions, but it's all going to work out in the end. Plus 16/3 x minus 35/3 equals 0. What's our next step going to need to be? We're going to add that 35 thirds to both sides. We're going to leave room, and we are going to be adding something to both sides. The question is, what? And I'll give you a minute before I spoil it for y'all. $64.9. So the million-dollar question is, well, how do we get that? Well, half of 16 thirds is 16/6 or 8 thirds. 8 thirds squared is 64/9. And the other thing is, if I gave one like this to you on a test, the answers are going to come out very nice. They're not going to have radicals. All right, so we know how this left-hand side is going to factor. Well, first off, let's do 35 thirds. Remember, alpha and y equals accesses that fraction menu easily for you. So 169/9 is what the right-hand side is going to be. However, what will the left-hand side factor into? Well, don't forget, it's just an x. Is it going to be plus or minus? Why plus? Because this is positive. And x plus what? Eight over 3. Yes. Perfect. See how systematic it is? Why is it 8 over 3? Square root of 64/9, which is 8 thirds. Well, where did the 8 thirds come from in the first place? Half of the middle term. Exactly. Perfect. So now we take the square root of both sides. X plus 8 thirds will equal plus or minus what? 13 thirds. So you can do this as two separate equations. Or you can just do it as one, like that. It doesn't matter to me. So let's see, we would get x equal to 5 thirds. X would be negative 21 thirds. Well, x would be negative 7. Now, these both would be able to be factored. talk about another way to solve quadratic equations. Now, before I move on here, let me just tell you, if you see on a test where I tell you to solve by completing a square and has a leading term that's not a 1, the answers are going to come out like this. The answers will not have radicals. However, if the leading term coefficient ends up being a 1, chances are it's going to have radical. That's okay. All right, any questions on completing the square? All right. So we have one more method to solving quadratic equations, and that, folks, is called using the quadratic formula. Now, you might be thinking, oh, crap, another formula I got to memorize. No, I will give this to you. In fact, yeah, I know some nerds that have actually had the quadratic formula tattooed on them. That's hard. See, I mean, I'm just not a tattoo kind of guy, but if I was going to get a tattoo, that's probably what I'd get. I mean, I just hate dealing with needles, nothing. So, you get negative b plus or minus the square root of b squared minus 4ac entirely over 2a. So, the quadratic formula is a, b, and c in the equation. We're going to figure out where those a, b, and c come from. Now, that plus minus, why do you think that plus minus is there? There are two solutions. Very good. Quadratic equations will have two solutions. Basically, it's of the form ax squared plus bx plus c equals 0. The other side has to have 0. Now, what happens, basically what happened in the 1100s or so, completing the square came before quadratic formula. They were able to complete the square of this to get the quadratic formula. That's exactly where it comes from. In case you want to know, I took a math history class, so yeah, they have those classes. So there is something special about a particular component of the quadratic formula. There's something under that radical called b squared minus 4ac. That is called the discriminant. The discriminant is going to tell us specifically how the solutions of a quadratic equation will be. And there are three specific directions: positive, negative, and 0. This is going to tell us the type of solutions that we have. Now, these first two equations, case 1 and 2, we already solved them. You might have to kind of look in your notes. X squared minus 2x minus 24. The solutions were 6 and negative 4. Now, all we're going to do here is find the discriminant. So, first off, A, what is in front of that x squared? Just a 1. So, A is 1. How about B? Negative 2. And C is negative 24. Good. Now, here's the thing. When solving by using the quadratic formula, I haven't seen it so much with college students, but when I taught high school, a lot of students would ask me, Mr. Jarrett, where's the plus minus button on my calculator? First thing you always do when you're solving with the quadratic formula is find that discriminant. B squared minus 4AC. So negative 2 quantity squared. Where do the y's put that negative 2? Put any negatives in parentheses. And I'm not going to make you like show each step. We're just going to figure out what the discriminant is. So negative 2 quantity squared minus 4. By the way, this must be a minus sign. Do not make that a negative. Because if you put a negative instead, it's going to be implying that you're multiplying. You will make, everybody makes that mistake. It's going to happen. Don't worry. A was 1, and C was negative 24. So the discriminant is 100. Now, for this next one, x squared minus 8x plus 16 equal to 0, what were the solutions? I'll give you a hint. It should actually be on the previous page. X equals 4, but it occurs twice. One unique solution. I want you to find that discriminant. I already know what it is, but I want you to figure it out for me, please. Can anyone tell me what the discriminant is? 0. B is negative 8 minus 4 times 1 times negative 16. This is going to be 0. So, and there's a connection that we're going to establish in just a few moments. And it's going to be awesome. Now, for this last one, the solutions are imaginary. We haven't covered that yet because we actually won't hit them until the third unit. But basically, this algebra, for the most part, has been around for almost 1,000 years, the algebra that we know. Imaginary numbers have only been around for about 500 years. So the discriminant, negative 6 quantity squared minus 4 times 1 times 13, what's the discriminant? Negative 16. Now, when we're finding the solution to these quadratic equations, we're going to end up taking the square root of the discriminant. So when you take the square root of a positive number like 100, it's going to be a nice number. But if we took the square root of negative 16, now see, my calculator is set only to real mode. These answers are not real. So the solutions to this particular one are 3 plus or minus 2i. But, again, I don't expect you to have to do that until unit 3. We're going to open it up in that third unit. So, is there a relationship between the type of solutions and the discriminant? The answer to that is yes, there is. So, if the discriminant is positive, how will the solutions look? You'll have how many solutions? 2 real solutions. Different. Let's call them different real solutions. Now, if the discriminant is 0, you have just 1 real solution. But it occurs twice. And if the discriminant is negative, you'll have 2 non-real solutions. And for unit 1 and 2, we're keeping it real. All right, any questions on this? All right. So, these are 2 equations that we did on a couple of pages ago. What I want you to do is identify the discriminant in each case, the square root of the discriminant, and see what happens. So you just have to look back at a previous page for your notes to find the solutions. So yeah, those are the solutions that we had from previous pages and whatnot. Now, for each of these, I'd like you to find out what the discriminant is and the square root of the discriminant. Let's see, the discriminant. 16 squared minus 4 times 3 times negative 35. You got to figure that out using the calculator. Yeah, don't try to do something without the calculator. Don't try to act like all big and bad. I mean, it is how I used to try to impress ladies, like, show them my mad calculating skills when I was in college. Nah, not really. I didn't do that. -4 times 3 times -35. That discriminant is 676. Now, the square root of the discriminant is what? 26. It's a perfect number. Now, could we have actually factored this? The answer is yes. X plus 7 times 3x minus 5. Now, in a minute, well, let's figure out the discriminant of this last one. So, -10 squared minus 4 times 1 times 7. The discriminant of this is 72. The square root of the discriminant, square root of 72, is simply, it's an irrational number. Like it's 8.485. Technically, it is 3 root 2, but 8.485, blah, blah, blah. Hey, wait a second. Doesn't that 3 root 2 look kind of familiar? We're going to see that in just a few minutes. It's going to be awesome. But could you factor this? The answer is no. Well, technically, you want me to get really technical, any polynomial is factorable. But it is not factorable over the integers. Not over the integers. But will you ever be expected to factor outside of integers? No. Trust me. It would be x minus 5 plus 3 root 2, x minus 5 minus 3 root 2. And this is way beyond your pay grade. You don't need to worry about that. I had to do this in a course called Abstract Algebra. Factor over the irrationals. Do you see a relationship between the discriminant and the factorability? Do you? What is it? I'm sorry? It is. There is a relationship. So think about the square root of the discriminant. If for the one that was factorable versus the one that was not factorable. For the one that was factorable, the square root of the discriminant was what kind of a number? A whole number, an integer. Then it's factorable over the integers. I mean, yeah, that's a technical term. You probably don't, factorable over the integers, but, All right, so let's go back up a little. So we already knew these solutions. X equals 5/3, x equals -7. Did you know that we can do what is called backdoor factoring? And by backdoor factoring, I mean we could actually convert those solutions into factors. Now, for this first one, if I want to get rid of this fraction, what can I do to both sides? What can I multiply both sides by? By 3. So 3x equals 5. Now, to make a factor out of this, all we have to do is subtract 5. Basically, 3x minus 5 equals 0. Whatever equals 0, that's your factor. We're going to see that a lot more in Unit 3. And x equals -7. Well, what can I do to both sides to zero out the right? Let's add 7. X plus 7 equals 0. And that's our other factor, backdoor factor. All right, so I'm not going to expect you to know it, but it is something worth knowing. All right, we're going to go on to the next page here, where basically, first thing you always want to do is find the discriminant. We're going to change this one. I'm going to change this one. I don't like that one. We're going to do x squared plus 6x minus 11 equals 0. So the first thing you always want to do when doing this, when using the quadratic formula, always find the discriminant first. That's what you're going to want to find first. So the discriminant, 6 squared minus 4 times 1 times -11 is what? 80. Now, we need to simplify the square root of 80. We need to break that apart. So we might have to do a little work to do that. Well, let's see. Two numbers that multiply to 80. 10 and 8. And 10 would go into 5 and 2, both prime. 8 would be 4 and 2, and then that 4 is just 2 and 2. So basically, 80 is, we see 4 2s and a 5. So we need how many of the same square root? 2 of them. So this is a 2, and that is a 2. So 2 times 2 is, we have 4 root 5. Now, that is going to be a part of the solution in just a moment. So, bringing up the quadratic formula, negative b plus or minus the square root of the discriminant over 2a. Well, negative b is negative 6 plus or minus, hey, we don't have to figure that out again because we already have it. Negative 6 plus or minus 4 root 5 entirely over 2. So best option we have here, split it up. Negative 6 over 2 plus or minus 4 root 5 over 2. Well, negative 6 over 2 is just what? You get negative 3. And what does 4 root 5 over 2 simplify to? 2 root 5. Remember, divide wholes by wholes, radicals by radicals. And that is your solution. All right, we'll come back at 3 o'clock. All right, so we got to figure out the discriminant of this bad boy first. So let's see, negative 12 squared minus 4 times 4 times negative 23 and 512. Now, on a test, I wouldn't give you one that big because, frankly, it is really big. However, 512, I would like to say, is a power of 2. Now, I know my numbers back and front, backwards and forwards because I've been working with them for so long. I know all my powers of 2. Square root of 512 would simplify to the square root of 256 times 2. Well, what is the square root of 256? 16. And again, I wouldn't give you one this big on a test. Like, the biggest radical I would give you on a test might be like 140. Yeah, I've actually written the first test. One thing I've conditioned myself to do is I actually fill out the test before I give it to you now. Even though I do the problems, on my calculator, I end up making an error somewhere. It happens. So for the quadratic formula, you have negative b plus or minus the square root of the discriminant over 2a. Well, since b is negative 12, the negative of negative 12 would just be what? Positive 12 plus or minus 16 root 2 over 2a. Well, what was a? So 2 times 4, 8. So let's break this apart. 12 over 8 plus or minus 16 root 2 over 8. What's 12 over 8 simplified to? 6 over 4, or better yet, 3/2. And then plus or minus, what? Well, 16 over 8, that's 2. And this is all I need. what some people would do is, or if you did this, like I know that there are so many problem-solving apps out there. Trust me, I know them all. Some of them would actually make that into one fraction. You don't need to. Just do what I do. All right, so are there any questions about using the quadratic formula? Now, yeah, your lab assignments, yeah, if you notice, yeah, lab assignments do have some repetition in them. One other thing is, if there's a question on a lab assignment that's due, that's upcoming and due, and we haven't covered it, you know, I'll let you know. Just don't worry about the problem or change it or something. You know, so it's not like I'm going to expect you to be able to do something without covering it. All right, so now I'm actually not going to go over these, and you're probably thinking, why not? Well, if you go to the Moodle page, with the notes today, with what we do today, the next part is 8 great quadratic equations. All right, everyone. So those can be done, yeah. So basically, and here's the thing, I show you how to do those multiple ways. So whether it's completing the square or using the quadratic formula, I show you how to do it either way. New one up. So we're going to get to page 16. Radical equation solving. How do we solve equations involving radicals? Well, it's actually pretty simple. You do have to remember that the square root of something is the same as raising it to the 1/2 power. You know, if we were doing cube root equations, which we won't do, trust me, they're the same as 1/3 power. Now, yeah, it's always good to have your calculator set to real mode for these. Now, let's solve a basic radical equation. The square root of x equals 3. Now, this is mathematically a mathematical explanation as to why we replace, you know, why we square both sides. Because the square root of something is the same thing as, you know, x to the 1/2. So the reciprocal of 1/2 is 2. So that's why we end up squaring each side. So that's how that's going to work. So similar to solving absolute value equations, we must get the radical by itself. Once you get the radical by itself, then you can raise each side to a certain power to solve. So square root of 2x plus 1 minus 2 equals 3. And we'll check the first couple of these, but it's not going to become really necessary until we get on this next page. So in order to solve that one, what do I need to do? My first step. We're going to add 2 to both sides. Square root of 2x plus 1 will now equal 5. Now that we have the radical entirely by itself, what do we need to do? We're going to square both sides. So you have 2x plus 1 equal to 25. 2x equals 24. X is going to be 12. Now, I wrote this blurb because, you know, when I taught this to high school, this was something that was on the state test. Basically, you know, where I was, our state test, everything hinged on that. It was like the principal held a proverbial gun to my head over test scores every year. Said, you know, if we don't get test scores up to this level, your next year is going to be miserable. And that's why my wife and I said, well, you know what, we're going to be here next year. It wasn't our fault. But yeah, it will work. So now I want you to try both of those for me. All right, so for this first one, what do we need to do? We're going to subtract 2 from both sides. Square root of 4x minus 7 will now equal 3. Now we have the radical by itself. Now, since the radical is all by itself, that's when we can do what? Square both sides. So 4x minus 7 equals 9. That's a 9er. And then all you got to do is solve it for x. 4x equals 16, x will equal 4. All right. All right, give you a couple moments on that last one. Looks like it wants to rain outside. Here's how I look at rain. Free car wash. Actually do have to fix my headlights or so. Well, I didn't have a night class this past spring, so yeah, I haven't really done much driving in the dark in my car. All right, we're going to add 10 to both sides of this. So we get the square root of x minus 7 equaling 2. So we're going to square both sides of this. X minus 7 will equal 4. X is going to equal 11. All right, any questions on these radical equations? So I wanted to do a couple of basic ones before we get into ones that have variables on the other side, such as this. We're going to get into some that might have what we call extraneous solutions. So the keyword is extra. And when you see it on a problem set or a test with a radical equation, the direction is going to be check for extraneous solutions. So we have the square root of 2x equal to x minus 4. We're going to have to square both sides, but the problem is we're not going to be able to just square the x, square the 4, and call it a day. We're going to have to do what with this x minus 4? Multiply them out. Okay, that's x squared minus 8x plus 16. All right, so we've gone from having a radical equation like that to now a quadratic equation. So, but what must be on the other side in order for us to be able to solve that? So what can I do to both sides? Subtract 2x. And here's the other thing. Anytime you get a radical equation, whether it's, it will always be factorable, because the final answers will be rational, like either a fraction or like 2/3 or just a whole number. These solutions to these will not involve radicals, trust me. So we have to check, well, no, we have to figure out how this factors. How's this going to factor? So x minus 8 times x minus 2 equal to 0. So basically, x equals 8 and x equals 2. Now, we're not done yet. We're not through. Because what we have to do now is we have to check them one by one to make sure they work. Now, there's a chance that both could work, or only one work, or none of them work. So, in the original equation, square root of 2 times 8 would equal 8 minus 4. Square root of 16 equals 4. That's true, isn't it? So, that's a good solution. Now, when we check x equals 2, square root of 2 times 2 equals 2 minus 4. Square root of 4 equals negative 2. And so what happens here, x equals 2 is called extraneous. So, before you start that, well, yeah, it doesn't matter. You can start it or not. So for that next one, trial version. So, yeah, what I do is when I do these equations, I use my calculator And see, that's a solution that works. Then what I do is, if I get an integer solution, I actually square both sides. I actually don't need to solve this, and see, it gives me both. Now, what might happen is I might get something like this. Now, basically keep trying numbers until I get something that doesn't involve a radical. That's basically how it works. All right, let's try that. Give me a moment on that next one. Bless you again. So for this next one, what do I need to do to both sides? We're going to subtract the 2. So we'll have x minus 2. I don't need the parentheses yet. X minus 2 will equal the square root of 3x minus 6. So now that we have the radical by itself, now there are some equations that I've had to do in the past that what's interesting is, yeah, in Virginia, for their standard, they would have equations that involve 2 radicals where you have to square both sides once and then a second time. But because they were multiple choice, I showed them how to get around that. We're going to square both sides. Now, this next one, by the way, is going to be really easy. Little FYI. So we got to get everything over to one side. 3x plus 6. X squared minus 7x plus 10 equals 0. And yeah, as I've said before, these are always going to be factorable. X minus 5 and then x minus 2 equal to 0. So basically, we have x equal to 5 and x equal to 2. So we got to check them both. One at a time. Now, what some students in the past would do is they would put the 5 here and then the 2 there. That is completely wrong. So if we check the 5, we'll get 5 equal to, let's see, the square root of 9 plus 2. 5 will equal 3 plus 2. Boom. 2 will equal 0 plus 2. Oh, they both work. It happens. And in case you don't believe, we're going to break out Mr. TI Inspire. We're going to break out the computer algebra system. How many of you would like to have a calculator like this? You've got to learn how to use it, though. Yep, x equals 2 or 5. All right, the next one with the 2 square roots, that one's actually very easy. Very simple. All I got to do is just square both sides. So 7 minus x equals 5x plus 1. What do you get for this one? X will equal positive 1, yeah? All right, give you a little bit to play with these last two. Okay, so for your next problem set that's due Thursday, yeah, you'll have everything everything in front of you, so you should be good there. All right, so what do I need to do to both sides of this to get started? We're going to add the 5. So square root of 5x plus 61 will equal x plus 5. Then you're going to end up doing what to both sides? Squaring them. Five x plus 61 will equal x squared plus 10x plus 25. Going from this to this, you don't have to like show every single step. Yeah. We got to get everything over to one side again. So how can I get that started? Subtract 5x and what else? Let's subtract 61 as well. Let's just do it in one shot. Ooh. Don't want to do that. X squared plus 5x, 25 minus 61. Yeah, I think that's what it is. I just needed to be sure. So we get to factor this. Yep, x minus 4 and x plus 9. So basically, x will equal 4. X will then equal negative 9. Now, here's the thing. If you're choosing which equation, when you check it, you can check it in the original, or you can check it in this one before squaring. I'm just going to use the original. Let's see, negative 5 plus, let's see, square root of 81 equals 4. Negative 5 plus 9 equals 4. Yep, I think that's right. And I think, let's see, negative 5 plus negative 45 plus 61 equals negative 9. I already know that's not going to fly. So you don't even have to write out like a sentence, say like, this is extraneous. Yeah, just write extraneous. Believe me, you'll be with me for almost 4 months. You'll learn what I like. All right, give me a moment to do that last one. All right, we got to get that radical by itself. And again, if problem set 4 has a radical equation. And as a matter of fact, problem set 2, the one that is due Thursday, has a radical equation. Yeah. Now, if you have questions, if you're stuck on something, please email me. I'm pretty responsive. Especially when my in-laws come to visit. And see, yeah, they don't go away. Well, to be fair, the part where my wife's mother and grandmother lived was a coronavirus hotspot, the part of Virginia where they lived, so we needed to get them out of there. And thank God for my man cave. All right, we're going to square both sides of this. X minus 1 quantity squared will equal 5x minus 5. And again, if you're not sure about how I get something, please please ask. That's why I'm here. X squared minus 2x plus 1 equals 5x minus 5. Well, we'll take away the 5x and add 5. X squared minus 7x plus 6 equals 0. One thing I try to do when I write out the keys to the problem sets and such, I try to use different colors as well. I hope different colors helps. See, when I first started teaching, I had to use an overhead projector and markers. And my school, they were so cheap. Like we had to reuse transparencies. That meant I have to wash them every day. All right, then what we need to do is check each of these and see which ones work or don't work. So let's see here. So if we check x equals 6, that is 3 times 6 minus 7 equals 2 times 6 plus square root of 25 minus 6. Well, let's see. 18 minus 7, that's 11, equals 12 plus 5 minus 6. Yep. How about x equals 1? Will that work? Well, I already know it's not going to work. 3 times 1 minus 7, that's negative 4. 2 plus 0 minus 6. 2 times 6. They do both work. How about that? Yep. All right, so, radical equations. So, Now, before we move on to the next part of the lesson, so I do want to show you something else here. So all of you have registered for your MyLabs. That's good. So when you go there, in addition to all the extra material I post, because it's cool to do that, if you go to multimedia library, like this is P section 7 equations, like you could see animations, video, PowerPoints. I'm not as big of PowerPoint, all this stuff. And you got to find now, see prerequisites, video, like solving radical equations. If you click on that,
Hey there, I'm Melissa, and in this video, I want to help you solve radical equations. A radical equation is an equation in which the variable occurs in the square root, cube root, or any.
So,
and then we can use the
shows you how to do
principle.
this.
Square root of 1 plus 3 is the
Now, the examples might be a little more basic, but, you know, there's a lot there for you. All right, so we're going to start up with word problems, modeling with equations. So we're going to get into one of my favorites, word problems. Why do we hate word problems so much? Or do you not hate word problems? Well, maybe we like word problems. So basically, it's a given. Read the problem several times. You know, I don't see this too much at the college level, but at the high school level, students would just like, I don't know how to, just look at a word problem. I don't know how to do this. Well, thing is, you got to learn. So you need to be able to figure out what it is you're looking for. Let X represent an unknown quantity, or you could use any other variable. Write any other expressions and then equations, and then you solve them. And then you want to check your answer you got in the wording. For instance, in problem set 4 or in problem set 3. For instance, there's a problem where we're going to build a sandy beach around a swimming pool. And it's going to ask you for the length of the beach. If you've got a negative value for the length, what does that tell you? You didn't do something right because there's no way length can be negative. Not in our world. Or, problem set 4, number 1, an investment problem. One of those are fun. You have to figure out how much you invested in each bank account or whatever. If you get a negative number for one of them, you did something wrong because you can't invest $8. Or if it came up with you got $1 million out of it, something's wrong. So here's incomes for various majors fresh out of college. 3 of the bars above represent the mean starting salary of physics, math, and chemistry majors. I did throw in, for good measure, biology and statistics. So, the mean starting salary of a physics major is $4,000 more than a chemistry major. The mean starting salary of a chem major is $4,000 more than that of a math major. Combined, their starting salaries are $174,000. We're going to figure out the starting salary for each. So, now, we can, we can use X or not. Now, how can we get something like this started? How can we start this? Well, first, let's let the salaries of math, physics, and chemistry be M, P, and C. So, can we come up with an equation? Let's see if we can come up with some equations. So the mean starting salary of a physics major is $4,000 more than that of a chemistry major. So I've highlighted that in blue. We're going to try to write up the equation that relates that. What would the equation be that can relate that? So mean starting salary of a physics major is $4,000 more than chemistry. So the mean starting salary of a physics major, we'll call that P, equal to what? Well, let's not call it X. Let's call it C plus 4,000. Now, you're probably thinking, oh, is this a system? No. Now, the mean starting salary of a chemistry major is $4,000 a year more than that of a math major. So how can I write that one? C would equal M plus 4,000. Now, let's say combined, their starting salaries are $174,000. So I can write out one equation. And what would that be? Just combine them right now. M plus P plus C equals 174,000. Now, what's the problem with this equation as it's written? We have three variables. We need to get that down to how many variables? One variable. Now, I cannot replace this M, but can I replace this P here? With what? C plus 4,000. Now, don't forget this C equal to 174,000. Can I do any other replacements? What can I replace these C's with? I can replace these C's with M plus 4,000. And here's what happens. M plus 4,000 for this, plus the original 4,000, plus another M plus 4,000, equals 174,000. So now we've gone from having three variables to two. Now, one thing we could have honestly done is we could have combined like terms maybe. So M plus 2C plus 4,000 equals 174,000. But it doesn't make a difference. Now, we could have done it that way, but we need to combine like terms here. So it would be 3M plus 12,000 equal to 174,000. 3M will equal 162,000. The salary of a math major is what? $54,000. So what does that make a chemistry major? How about a physics major? 62,000. Add up these three and tell me what you get. You get the 174. All right, so what will happen next class is we'll work on these modeling, and then we'll get into any absolute value inequalities and some other modeling ones. So, all right, so before you go, just to let you know that so Best Buy is having a special on, good afternoon, ladies, 55-inch televisions. Now, after a 20% discount, the selling price before tax was $680. I really need to update this because a 55-inch TV is not that expensive anymore. Yeah, I know, like, my parents got a 75 for their living room. I'm like, oh, man, my wife will not let me get a 75 for the living room. Well, we just don't have a place to put it. Like, it'll cover the window. But she said, you know, if I can, you know, if I work and get the money myself, she'll let me upgrade my man cave TV, which would be good. And really, you know, it's quasi outdoor, but it's a little more exposed to the elements, you know, because, so I'm not going to like go and get like the fanciest TV there is. All right, so after the 20% discount, so if we let X be the original price, so X is the original price of your television. Now, from that, we're going to subtract something. Namely, what is it that we are going to subtract? We're going to take away 20% of what? The original price, which happened to be X. So here is your discount. And that will equal $680. So you'll be able to easily simplify the left-hand side, you know, x minus 0.20x, or 1x minus 0.20x. So it's going to be 0.80x, yes. 0.80x equals 680. And then we can divide both sides by 0.80. And X is going to be what? $850. And I have 55-inch in my living room. I paid $900 for it, but that was 8 years ago. I mean, it still works great. So that'll be good. Now, the next problem I'm going to have us talk about the length of a rectangular hockey rink. Now, you know, hockey, that's a game where they play either on rollerblades or ice. You know, Carolina Hurricanes. You know, hockey. You know, when I was growing up in Pittsburgh, basically, you know, Pittsburgh Penguins were back-to-back Stanley Cup champions. So the length of a hockey rink is 50 feet more than its width. If the total perimeter, now, what does perimeter mean? The distance all around. So we can call these widths and lengths, or vice versa. It really doesn't make a difference. Now, basically, we can come up with an equation, 2W plus 2L equals 388. Now, we can replace something. The length is 50 feet more than the width. Or you could say the width is 50 feet more than the length. It doesn't really make world of difference. But, so I could replace this length, these lengths with what? Not W minus 50, W plus 50. So we'll have 2W plus 2, but instead of L, we'll do W plus 50 equal to 388. Now, you went from having an equation with two variables and then now down to one. So this is an easy one to solve. If 2W plus 2W plus 100 equal to 388. 4W plus 100 equaling 388. 4W equals 288. And you take that 288 and divide it by 4. What do we get? 72 feet. So if the width is 72, what is the length? Even though this drawing is not an entirely accurate representation, it's going to be 122. 50 feet more. I enjoy watching hockey, especially the fights. Hockey fights, pretty fun to watch. Now, if you were to add 2 times 72 plus 2 times 122, tell me what you get for that, please. $88. See how it all works out? That's the BEA beautiful thing about word problems. It all works out ever so nicely, especially when you do it right. Now, I am a big fan of this type of problem, a swimming pool problem, which we are actually going to cover more than one of these. And I'll tell you, there is going to be one on your test. There are some in your labs. Yeah, not the lab that I just collected. So, nice work on those first labs for the most part, by the way. Very nice. So, the width of a swimming pool is 20 by 30 yards. It's kind of a small pool, but now, there's our pool. 20 by 30. So, what's going to happen here is we're going to actually construct a C&D beach of uniform width around that pool. Now, it could be a concrete beach or whatever. But now, even though the drawing might not completely accurately reflect that because my drawings usually suck, here's what happens. The area of the beach and the pool is going to be 1,200 square yards. Now, area of a rectangle, surely you know how to calculate that. Length times width. Easy come, easy go. Now, what some people would do is they would see, oh, the area of the pool is 600 yards. Or square yards, 30 times 20. But, and then, if you remember from your, well, I guess it's Math 2 down here, or geometry, you could actually subtract the area. But see, here's the thing. It would be really hard to figure that out. But here's the thing. Remember, we can make x one of our unknowns. We can make an unknown x. This uniform width or size, I would actually say length or width or size x. So that's kind of the key to solving this. Now, the original length was 30, but we are going to add something to that. To include the white sandy beach area. What is it that we are going to add? I hear an x. Now, is it just one x? It's going to be two x's. Very good. And I promise you this. Any of these area and pool problems, this is exactly how it's going to look. Now, our width, instead of just 20, our width is going to be what? (20 plus 2x). Very good. So, now, we have our length and our width. It doesn't really matter what we call length or width because the calculation in the very end is going to be the same. So, what happens here is, area is length times width. So 30 plus 2x times 20 plus 2x, it's going to have a product of what? 1,200. So, now I always like to put the variables first. 2x plus 30, and then 2x plus 20. I mean, it really doesn't make a difference. But so, when you multiply these two out, what's going to happen, folks, is you are going to get a quadratic equation when all the smoke clears. And the quadratic equation is easily solvable. Whether you choose to complete the square, factor, or use the quadratic formula, it doesn't really make a difference because, it's going to be simple. Let's just say that. So when I expand this out, 2x times 2x is 4x squared. 30 times 2x is 60x. 20 times 2x is 40x. 30 times 20 is 600. And this all equals 1,200. Now, I need to combine my like terms here, plus 100x, plus the 600, and that'll equal 1,200. Now, so there's a quadratic equation. Now, these numbers look very daunting. Don't fret, because, well, first thing you need to do would be what? We're going to subtract that 1,200 from both sides. So we take away 1,200. We get 4x squared plus 100x minus 600, now equal to 0. Now, it's true, you can shove this into the quadratic formula and be done. But here is a very nifty thing. What could I divide everything by? I could just divide everything by 4. And here's the thing, the problem that's on your test will work the same way. the x that is on your test will be a whole integer. You know, it won't be like 7.2 feet or whatever. So let's divide everything out by 4, and let's move this up here. So we'll have x squared plus 25x minus 150 equal to 0. So we have a much easier looking quadratic equation to deal with here. Much easier. And actually, I've been, I've written the test and I got sidetracked with something. I was actually writing the key to make sure the problems worked out. And there was one question, and I said, no, wait, I think I threw something in here I should not have, so I have to change the question, but, So, we can find two numbers that have a sum of 25 and a product of negative 150. I'm sorry? 70? 30 and 5. Well, I think that should be negative 5. So basically, this will become x plus 30 times x minus 5 equal to 0. X equaling negative 30. Now, obviously, that is not going to work. So what you can do with that is throw it out. However, x does equal 5. Now, even though we have our solution, it is right. What is 30 plus 2 times 5? And 20 plus 2 times 5? What is 40 times 30? Isn't that our area to begin with? So, ladies and gentlemen of the jury, this tells us that we have done it all right. So, now, because this is a word problem, and I'm actually going to include a blurb on it saying whatever the quadratic equation is, I will allow you to just use a calculator to figure out. So I don't know if I showed you this or not, but if you go to apps, I don't want the key press history yet. Okay, well, I guess I have to do it over here. Make it listen to me. There we go. Under polysimult 2, that is the polynomial root finder. Now, we're going to use that. The order is 2. It's a second degree equation. Now, we can leave it in real mode. We can enter the coefficients. Now, the newer app model actually allows you to change the sign. I hate doing it. So the equation as written, or the reduced equation. Now, how many of you have your own calculator but don't have this on there? I will load it for you next class. I forgot to bring my laptop to do that. But yeah, trust me, I will have it for you. So, 4x squared plus 100x and minus 600 or plus negative 600, I prefer it this way. There it is. Plain as day. Pretty neat. And don't worry, next class, I will have my laptop here with TI Connect, and I will load that for you. Just remind me. All right, so that's how we do it. Now, A radio tower is supported by a guide wire that is 200 yards long and 100 yards from the base of the tower. So here's our tower. Now they're asking how tall is the tower. So this is going to be our unknown. So here, 100 yards from the base of the tower. So this length is going to be what? 100. And the guide wire is 200 yards long. What kind of problem is this? The Pythagorean theorem. Now, I'm not going to make you simplify, give it its simplest radical form. But for something like this, x squared plus 100 squared will equal 200 squared. Now, why is 200 squared by itself? It's the hypotenuse. By the way, if you've ever seen the skit, the Key and Peele skit, where he says, I wish I was high on hypotenuse, that is pretty dang funny. So x squared would be 200 squared minus 100 squared. And we get 30,000. And we just take the square root. And let's just round up to the nearest whole number. $173 yards. Excuse me. Now, another word problem that I so enjoy are these lottery problems. Now, I'm only going to give you either a pool problem or a lottery problem on the test, and I'll tell you it's a pool problem, I believe. I just want to double check, because, but it's only one. So, y'all know how a lottery jackpot works. It used to be you couldn't buy, like, if you bought a ticket, someone else could buy a ticket with those same numbers. That's not the case anymore. So theoretically, a number of people could buy, multiple people can and will buy a winning ticket. Now, so for a $12 million lottery jackpot, a given number of winners held the same ticket, so the prize is going to be split. So, yeah, like when someone won, when I think the highest Powerball or Mega Millions was over $1 billion. In fact, I really want to look that up real quick. Well, that was an individual one. Yeah, jackpot. The biggest jackpot was at $1.5 billion. And there were 3 tickets that were sold. So, the cash value, you can take it as cash winning or an annuity, but then you still got to pay taxes, but big deal. That's a couple $100 million that you didn't have before. So yeah, what happens is a given number of winners hold the same ticket, and the price is going to be split. Now, so a number of winners declared, and they're all about to get an equal share. However, 5 more winners come forward. Now, in our reality, once a lottery drawing is done, within seconds, they're able to say, okay, there were 3 tickets sold with this number, and they were here, here, and here. But let's just say, you still got to come forward. So how many original? So before the money is divided, 5 more winners are declared, thus reducing each person's share by $200,000. Oh, darn. So how many original winners were there? Well, guess what? That is going to be our unknown. Our unknown of X. Now, you're probably thinking, oh, how the heck do I set this up? Well, it's actually pretty straightforward here. What we're going to do here, so X is the number of original winners. Now, in terms of X, how many total winners were there? X plus 5, very good. That is the total number of winners. So that's going to make things a little easier. Now, we can set this up in 2 different ways. So, basically, it's going to be each person's share equal to something. So, we take this $12 million and what we'll do, that $12 million is going to be split altogether over X plus 5, divided by X plus 5, whatever X is. Now, it's true, for my math lab, for a problem like this, you could probably just try numbers, because it's got to be a whole number here. There's no, half people here, unless midgets, but, midgets do count as one winner. So so basically, let me reiterate, I think there's a better term to reiterate this. Winner's final share. Now, that is going to be equal to something. Now, so, let's say just arbitrarily X was 10. I don't know. Basically, that means there were 15 winners. 12 million is divided by 15, boom. But the winner's final share, so what happens here? We have 12 million. And let's just say originally it was going to be divided by X. But what is each person's share reduced by? 200,000. And since this is each winner's share, this 200,000 is not multiplied by anything. So, now, you're presented with some relatively large numbers here. Don't fret. Because we can, this is all going to clean up ever so nicely. But this looks like a rational equation. Now, one thing that could be done, these are all numerators. One thing we could do, and in fact, that would be true of any problem here. Let me just double check here. No. I believe, yep. So one thing we could do is we could simplify this by dividing all of our numerators by something. And that would be 200,000. Whoops. Because everything will work out. If we divide everything by 200,000, so what is 12 million divided by 200,000? $60. And here's the thing, it will work out on anything. So yeah, we're going to divide all numerators by 200,000. So basically, we get 60 over x plus 5 equal to 60 over x minus 1. Now, doesn't this look a lot nicer? This looks a lot nicer, doesn't it? Yeah. But do you see why we were able to do that? Divide everything by 200,000? You know, that is legal to do. So, we need to identify our LCD. We did that on day one. What is our LCD for this particular problem? What are the two denominators? X and x plus 5. So we'll put a 1 underneath that. So basically, we're going to multiply everything by x times x plus 5. And now we can offset some of this stuff. So you would get 60x equal to 60 times x plus 5 minus x times x plus 5. So now you'll get a quadratic equation out of this deal and be able to simplify it. Perfect. All right, good. So we do the math. 60x equals 60x plus 300 minus x squared minus 5x. Now, what is one thing I could do right off the bat? I could actually take away 60x on both sides. So basically, I have 0 equal to negative x squared minus 5x plus 300. So now I have, yet again, another quadratic equation. Well, guess what? We have done so much work already that we're going to use the app. And I'm going to make darn sure that that's loaded for you. So let's go to it. Who needs this on their personal calculator? Just you? Well, you know what? I think I have my own here that I'll just let you use for now. But I hope Darnell actually have a table here. So if I do, I'll be able to do it that way. I'm so sorry. All right, polynomial root finder. It's a second degree again. This time, negative 1x squared minus 5x plus 300. So we're going to solve that. Now we're going to get x equal to 15 and x equal to negative 20. Obviously, the negative 20 doesn't work. But that's our answer, 15 original winners. Now, here's the thing. Even though we have our answer and technically we're done, I'm going to take this just a little, and by me, we're going to check this. So 15, remember, is the number of original winners. If you take 12 million and divide it by 15, what do you get? How much? $800,000. Not bad. I mean, $800,000 for me wouldn't be like retirement money, but I'd be able to pay off my mortgage, have a car, and just keep working. Now, if we had 15 original winners, how many total winners is this? 20 total. Take 12 million and now divide it by 20. You get 600,000. What is the difference in the winner's share? What was the supposed difference in the original problem? See how it all works? Pretty cool. All right, so what I'm going to do, we're now going to build a swimming pool for Sandy Beach of uniform length or size surrounding it. Now, the pool itself is 50 by 100 yards. However, the area of the Sandy Beach, not a circle, that would make all kinds of. The area, and I should have said, of the pool and the Sandy Beach, it's going to be 10,400 square yards. So basically, what will our length, this is 100 and this is 50. So our new length is going to be what? $100 plus 2x, and this will be 50 plus 2x. So basically, 2x plus 100 times 2x plus 50 would equal 10,400. Now, if you really wanted to be savvy, I could actually, what could I factor out of these? I could individually factor 2's out. It really won't make a difference. Well, I mean, it will. So this will be 2 times x plus 50 times 2 times x plus 25 equal to 10,400. 4 times all of this. And then what could I divide both sides by? And here's the nice thing. It will always work if you choose to do it this way. X plus 50 times x plus 25 is now going to be 10,400 over 4. Which will be 2,600. much easier to deal with. So basically, we have x squared plus 50x plus 25x plus whatever 50 times 25 is. I should know that, but 1,250. Then I'll take away the 2,600 from each side. X squared plus 75x minus 1,350 equal to 0. Now, you can use your calculator to come up with the answer to this. And in fact, I'm going to put a blurb on your test saying as such. Yep, you have been upgraded. No problem. And what do we get? Okay. I think doing this, I've never actually presented this way before. Wait, no. 2 times x plus 50 plus 75x. All right, I got to see where I made a mistake. Well, I'll tell you what. We'll figure that out at 3 o'clock when we come back from break. All right, so we have $250 million lottery jackpot. That's a lot of money. Yeah. Real life Snoopy. See, they say Snoopy is a beagle, but see, that is not a beagle. That looks like a doodle of some kind. Like maybe a labradoodle or something. So X is the number of original winners. And how many more winners did we get declared? So X plus 2 is the total number of winners. So we'll take this 250 million. We're going to divide out in a minute. Over X plus 2 equal to 250 million over X minus $6,250,000. Now, let's divide each numerator by 6,250,000. So what is 250 million divided by $6,250,000? 40. Yeah, see, this makes it much easier. You have 40 over X plus 2 equal to 40 over X minus 1. So yeah, a lot easier. So what is our LCD going to be? X times X plus 2. So we'll multiply all of our numerators by that. Make the appropriate cancellations. We'll have 40X equal to 40 times x plus 2 minus x times x plus 2, then we can distribute 40x will equal 40x plus 80 minus x squared minus 2x. Well, what can be removed from both sides right now? 40x. So now we have 0 equal to negative x squared minus 2x plus 80. You're going to punch that up in your polynomial root finder. Tell me what you get. Take only the positive version. Yeah. How do you get to that? Well, what you do is you go to apps and polynomial 2, polynomial root finder, and next, and then you enter the coefficients. You want order of 2. We're only going to be doing order of 2 for the time being. Well, only in this unit. So x is going to be 8 original winners. Now that means we would have 10 total. But 8 original winners is all I am worried about. Did you find the app? All right. Go to hit the app button. Always sign up to it's option 7. So yeah, well yeah, I have to ship. So basically, yeah, that's quite a lot of money I would have. And yeah, you can never have too much money. I don't know. I mean, yeah, I'll say, Forrest Gump would say, yeah, there's only so much fortune a person really needs. But then again, I don't know the life of luxury or anything. All right, so that's how we do that. So we're now going to get into inequalities and interval notation. So parentheses indicate we have an open interval, and brackets indicate a closed interval. So today, we're probably going to, well, we are going to do some inequalities today because, it will help you with interval notation. Because anytime you do an inequality, for particularly absolute value ones that we're going to be talking about definitely next class, your final answer will be expected to be in interval notation. So if the interval is A and B with both parentheses, now what I'm going to do is I'm actually going to draw my graph first. Now, A and B, neither one of those are actually included. But I'm still going to shade between them. Now, set builder notation, x given that, what I really care about is this. That x and that bar basically means x given that. But the main idea for set builder notation, this is enough for me. That's it. So now if A and B are both bracketed, Since now A and B are going to both be bracketed, that means both A and B are included. So this set builder, X given that, we're going to be including these. Now, A is always going to be less than B here. So for this one, the A is not included, but the B is. So A will just be less than X, but what about it will be less than or equal to B? So the A is not included, but the B is. Now, for this one, the A is included. But what about the B? Not included. Now, we're dealing with A to infinity. Now, you might have to, it might be better to draw the graph first. So in this case, is the A included? No. But we're still going to go above the A, but there is no upper bound. Now, infinities will always have parentheses. You're going to see that particularly when we get to intervals. So X is given that X is just simply greater than A. Now, in this case, the A is included. Now, these next two are where they end at B. However, they're preceded by a negative infinity. In this case, the B is not included, but in this case, the B is. But which side would I want to shade? To the left. X is less than B. X is less than or equal to B. And again, the braces in that, basically, this is like how a mathematician would write it with that. But a set builder. Yeah. Now, what about this last one? This is all reals. So the technical term is X. It looks like an E, but this E means belongs to. That's actually a Greek letter epsilon. And this R is all reals. And basically the entire thing gets shaded. Any questions? All right. So I'm going to talk about intersection and union. Now, intersection belongs to both sets signed by an upside down U. We're not going to be dealing with intersections very much, but we are going to be dealing very much with union. So we're going to use graphs to find each set. Now, union means it belongs to either or both. So I'm going to draw number lines for these regardless. Need a straighter line for that. So what I'm going to do here, -1 to 3, I'm actually going to graph that in red above the line. And then 2 to 7, which I will do in blue. So basically, a union means it belongs to either one or both. So we actually don't need to make a second graph here because, we're going to just be able to identify the intersection for that one. But here, the union, it has to belong to either one or both. The union would start at -1, and where would the union end? 7. Now, would that 7 be a parenthesis or a bracket? Parenthesis, because that 7 is not included. Now, the intersection would be, the intersection means it has to belong to both. So where would the intersection start? From 2. Now, would that 2 be a parenthesis or a bracket? It would have to be a parenthesis because 2 is not included in both. But that 3 would be a bracket. So, for this first one, what can I do to get that one started? Let's subtract 2 from both sides. So I get -3x is less than or equal to 3. Now, what do I need to do to both sides of that? Now, since I divide by a negative, the sign gets flipped. X will be greater than or equal to -1. And that's it. Now, thing is, this is also going to be excellent practice to do graphing and interval notation. Now, graphing, what I mean by that, since it's just x is greater than or equal to -1, all you have to do is just put a -1 there, open a closed dot. Close it up, and which way am I shading? To the right. So there's your graph. Now we're going to do interval notation. So, read it from left to right. Where does my interval start? -1. Now, would that be a parenthesis or a bracket? That's going to be a bracket because it is included. Now, and it goes to infinity and beyond. However, infinities always get parentheses. All right. All right, let's do this next one. How can I start the next one? Just 7? Subtract 7x. I knew what you meant. Negative 4x plus 1 is greater than what? Negative 15. So what can I now do to both sides? Subtract 1. So we get negative 4x is greater than negative 16. And now we're going to divide both sides by negative 4. Now, since we divided by a negative, we flip the sign. X will become less than 4. So I'll put that on a number line, put a 4 in the middle. We'll leave it open because in this event, it is not included. Now, which side am I going to shade? The right? Less than. I want to shade it to the left. How many of you have trouble remembering your left from your right? The way to remember, hold your fingers out in L's. L means left. I'm staring at an L, that's a left. Of course, I remember a shopping center that was down the street from my parents' house. There was a sign coming out that said no left turn, because if you made a left turn, you'd be going right into traffic. Of course, Full Metal Jacket. Yeah, Gomer Pyle didn't know his left from his right, so the drill sergeant slaps him hard across the face and said, "Now what side was that?" Then he does it to the other side. He didn't forget. You know, that movie was all sorts of. But thing is, yeah, that's just. Well, it depicts things, different times. All right, compound inequalities. Now, I'm bringing this up because technically our absolute value inequalities are compound inequalities. Now, they can be joined by and or. Now, the nature of the solution will depend on whether they are joined by and or how they're combined. So basically, if you see an inequality written like this, it can actually be written as x is greater than a and x is greater than b, or less than b. So technically, when it's an and, it would have to satisfy both. Now, I'm not going to make you write this out here, but for food for thought here, x is going to be greater than or equal to negative 4, and x is going to be less than or equal to 2. Now, what this and means is it has to satisfy both. So, if I plot this, now basically it's between negative 4 and positive 2. Here's the thing. One way I can do this, if I were to actually plot, x is greater than or equal to negative 4, it would be that. Whoops. And less than 2. What do yellow and blue make? basically, in this case, you'd be looking for an overlap. So this is just further evidence that this is the desired answer. And we'll go from -4 to +2. We will see this when we introduce the absolute value inequality next class. All right, now if they're joined by OR, what you're going to see here is that these inequalities will diverge from each other. That means they'll go off in different directions. That's okay. So x is less than -2. So I need to shade this to the to the left. Or x is greater than 5, greater than or equal to 5. So we have two different intervals. Guess what? This is where the union comes out. This first part is from -infinity to -2. Now that -2 gets a parenthesis or a bracket. Parenthesis, very good. And what will happen, it's going to be joined together by u, and the technical term, we're saying union with 5 to infinity. So, I want you to solve both of these. What we can do here is basically treat this as a three-sided one. We can subtract 3 from everything, giving us -2 less than or equal to 2x less than or equal to 8. And then what can I divide everything by? Divide everything by 2. Now, it's true, I could have split this into two inequalities if I really wanted to. But x is going to be between -1 and +4. If we graph it, it'll look just like this. And the interval, how will this look in interval notation? Where will it start? -1, and where will it end? Now, what do I put here? I'm putting brackets on them both. All right, now, for this, we have two individual inequalities. So, I don't know, let's see. I'm going to subtract 5x. I could have subtracted 6x, but I always like to have my variable on the left side of an inequality, or I can always just flip it over. Now, if I subtract 3, even though there's a negative here, do I flip the sign? No, I do not. X is less than or equal to -7. Now, 8x minus 2 less than 10x minus 10. So, I think I'm going to do this. I'm going to subtract 8x from both sides. (2x minus 10). Consequently, I'll then add 10 to both sides. And I'll get 8 less than 2x. I can flip this. So I get 2x is greater than 8. I divide by 2. X is greater than 4. And since there was an or here, we still do it that way. So the graph, -7, it's included, I shade to the left, +4. Is that one included? No. And I shade that to the right. Now, the interval, so I start at -infinity, -infinity to -7. Now, will that -7 get a parenthesis or a bracket? The -7 is going to get a bracket. Because there's going to be a second interval here, we put the union from 4 parentheses to infinity. So, when we get into absolute value inequalities in the next class, what's going to happen is you're going to be regular experts at interval notation. So, here's a couple of word problems. All right, so we're going to rent a car from Basic. It's going to be $220 a week with no extra charge for mileage. Continental charges $70 a week plus 25 cents for each mile driven. So basically, X is going to be the number of miles. So we want Basic to be a better deal than Continentals. In other words, the cost for Basic has to be less than Continental. So Basic rental, what is the equation in terms of X for the cost for driving a car for Basic? Just 220. This is a 1-week rental, by the way. So, yeah, you pay $220 regardless, whether you drive it 1 mile or 100,000 miles. I'd like to see that. Less than Continental. So what is the equation that represents Continental? 70 plus 0.25x. So all we have to do is solve this for x. So 220 minus 70, I believe, is 150, less than 0.25x. If we divide out by 0.25, we get 600 less than x, or x is greater than 600. So basically, Basic is the better deal when you drive more than 600 miles. Now, this last one, I'm just going to kind of brush through. In a class, you have 4 exams. Basically, we'll have a compound inequality. 60 will be between, you take 74 plus 58 plus 83 plus x, dividing it by 4, is less than 70. Well, what would the first step be to get rid of that fraction? Multiply by 4. So 240 is less than Well, whatever that is, let's see what that adds up to. $215 plus X. And that will be 280. So if we subtract 215, this basically gets you a C. So, all right, we're going to stop it here because we just don't have time to record this. So here's what happens with these absolute value inequalities. So what's going to happen here is both of them, so you'll get x minus 3 less than or equal to 8. And you'll get a second one, x minus 3 greater than or equal to negative 8. Now, what's going to happen here is you're going to solve the both of these. So x will be less than or equal to 11. X will be greater than or equal to negative 5. Now, if we plot these on a number line, what happens here, this is going to be a compound inequality. Now, so for x to be less than or equal to 11, it's going to look like this. However, for x to be greater than or equal to negative 5, it'll look like this. So when all is said and done, so what I want you to do here is pick a value that is greater than 11. 12. 12 minus 3 is 9, so is absolute value of 9 greater than 8? No. Now, what happened here was it only works for this particular one, but it would have to have worked for both. Now, something that's between negative 5 and 11. 0. Now, if we took 0 minus 3, the absolute value of negative 3, is that less than or equal to 8? Yes. Now, if we tried something in the yellow-only region, such as negative 6, the absolute value, negative 6 minus 3, that's negative 9. The absolute value of negative 9 is what? 9. And is that greater than 8? Or, is that less than 8? So basically, what happens, this basically is an intersection. So we would join these together by the word and. So basically, x would be between negative 5 and positive 11 inclusively. And for the interval, we would just go from negative 5 to positive 11. Now, the other one, this is how the other one will work. So we'll get x plus 2 greater than 5, greater than or equal to, x plus 2 less than or equal to negative 5. So we're going to solve both of these bad boys. For this, we would get x is greater than or equal to 3, less than or equal to negative 7. Now, if we plot these on a number line, negative 7 and positive 3. We're going to do the negative 7 in a yellow highlight. So negative 7, would I want to shade to the left or to the right of that? I want to shade to the left. And if I decide to do, greater than 3, I want to shade that to the right. So basically what happens here, these answers diverge. Now, what happens here is if we pick something like maybe negative 8, that fits that inequality. So basically, it has to be either one or both. Actually, both of these do. So what happens here, the final answer is simply x is less than or equal to negative 7, or x is greater than or equal to 3. Now, for the interval, we're actually going to have 2 separate intervals. The first one will go from negative infinity to negative 7, bracketed, union with 3 to infinity. So, now the big question is, do you see that there is a relationship with the direction of the inequality sign and the resulting answer? So if absolute value of x is less than something, we'll just call it a constant. And we'll compare that with absolute value of x is greater than something. Is there a relationship between the nature of the final answer? If it's less than or greater than, or less than or equal to, greater than or equal to, same idea. Well, if it's less than, basically what you see here is that effectively you would be taking the overlap, or it would be between two values. X would be between these two, and basically you would be taking the overlap or intersection. Now, and these two inequalities, when you split them up, are joined by the word and. Now here, the answers diverge. It's going to involve a union, and they're going to be joined together by the word or. All right, so any questions on this? All right, or we can do it outright. Now remember, when you divide or multiply by a negative, you've got to flip that sign. So we're going to work through the first one or two together. So for that first one, we've got, well, for any of these for that matter, what do we have to get by itself? We got to get the absolute value by itself first and foremost. So to do that, what would we have to do? We're going to subtract 5 from both sides. So now we have the absolute value of 2x plus 1 is now less than or equal to 9. Now that the absolute value is in fact by itself, what we now have to do is simply break this into two separate inequalities. So 2x plus 1 is going to be less than or equal to 9. Now, are these going to be joined together by an and or an or? And 2x plus 1 greater than or equal to negative 9. Remember, for the other inequality, you have to flip. So we solve these both. 2x is going to be less than or equal to 8. X is going to be less than or equal to 4. So 2x will become greater than or equal to 10. X will be greater than or equal to negative 5. Now, was I supposed to flip the sign on that second one? No, because what did I divide by? I divided by a positive, even though that value had a negative in it. I still divided by a positive 2. So now, what's going to happen here is basically we're going to go between two values. X has to be less than or equal to 4, and it has to be greater than or equal to negative 5. So basically, and there are no exceptions to this, basically it's just between these two. Now, what would the interval look like? Where would it start? It would start at negative 5, and where would it end? Positive 4. All right. Let's work through this next one together. So, what is the first step going to be? Divide by negative 6. Oh, we're dividing by negative. What happens to the inequality? We flip it. So, since we divide both sides by a negative, we now get absolute value of 7x minus 10 less than or equal to 4. So now we are going to get two inequalities out of this. 7x minus 10 less than or equal to 4. 7x minus 10 greater than or equal to negative 4. Now, would these be joined by an and or an or? Less than. So it's and. One of these answers will have a fraction. Let it be. All right. So we'll get 7x less than or equal to 14. X will become less than or equal to 2. So 7x will become greater than or equal to 6. X will be greater than or equal to 6/7. So if we graph these, obviously 6/7 and 2, less than or equal to 2, greater than or equal to 6/7. the interval would start where? And would we have parentheses or brackets? We would have brackets. All right. We're going to work through this next one together, and then I'm going to give you a couple of moments to solve the next ones. So what would our first step be? We're going to subtract 4 on both sides. That's right. So 8 times the absolute value of all this is going to be greater than 8. What will happen now? What will we do to both sides? You're going to divide by 8. So we have the absolute value of x over 9 minus, x over 9 minus 4 is greater than 1. So now we're going to get 2 inequalities out of the deal. First one, we take it as it's written. X over 9 minus 4 is greater than 1. And the other one being x over 9 minus 4 less than negative 1. Now, are these going to be joined together by an and or an or? By an or this time, because that is greater than, so basically we're going to get a diverging answer. So we'll add 4 here. So x over 9 is going to be greater than 5. Now, if x is divided by 9, what would I need to do to both sides? Multiply by 9. See, these type of equations really scare people. They shouldn't. So x is going to be greater than 45. So x over 9 will become less than 3. X will be less than 27. So we plot on a number line. We want to be less than 27, but greater than 45. So these answers diverge. So what's our interval going to look like? Negative infinity to positive 27. Very good. Now the 27, will that get a parenthesis or a bracket? Parenthesis. Now what will combine these? A union sign. And we go from 45 to positive infinity. All right, I'm going to give you guys a couple of minutes to putz these next 3. Recorder. So for this next inequality, what do we need to do to both sides? We're going to take away the 7 from both sides. So now we have 5, absolute value of 5 minus x over 3 is less than or equal to 2. All right, so this is going to look intimidating, but it's really not. What word will I use to join these, an and or an or? And. Very nice. Now, I'll be blunt with you. Your test question will look something like one of these two. You can tell what I really like to ask. You know, one thing you're going to get to know is, oh, Mr. Jarrett likes to ask these types of questions. Now, we're going to multiply both sides of that by 3, but negative 3. Excellent. I can read your mind, you know. At least, well, no, not like in a creepy manner. So, x is going to be less than or equal to 9. Did I do that right? No. What did I do wrong? I didn't flip the sign. Don't be offended to tell me that if you think I did something wrong. I mean, don't think I will be offended. You know, I make mistakes. I mean, my parents made one 39 years ago. I'm kidding now. So we take away 5 from both sides of this bad boy. We get negative x over 3 greater than or equal to negative 7. We multiply out by negative 3 on both sides, just like before. And we get x is less than or equal to 21. Now, even though we flip signs here, this is still an and inequality. Greater than or equal to 9, less than or equal to 21. And of course, the interval would go from 9 to 21. All right, not bad. All right, so for that next one, do I want to, I do 2 minus 3, don't I? Do I do that? Is that what I do? You are telling me no? Of course you're right. Yeah, you're right. No, I would never get intimidated. No, I'm just playing. Now, what do we got to do to both sides of this? We got to take away the 2 from both sides. What's the use of doing a job if you don't like it? That's true, but I mean, I don't make that great. I mean, I make good money. I mean, I don't live in a fancy house or drive a fancy car. I drive a 13-year-old clunker. But you know what? I'm happy. Because I go home at night, you know, I wake up in the morning like, oh, I can't wait to get to work. Although I wish, you know, I did like working from home, you know, with the dogs. That was cool. Yeah. All right, we're going to divide out by negative 3, and I need to flip the inequality sign. So then we get 2 inequalities out of the deal, 6x minus 9, less than or equal to 33. I didn't flip the sign. Oh, man. Like catching my mistakes. I didn't actually mean to make that mistake. But that's okay. So we're going to add 9 to both sides here. X is going to be less than or equal to 4.
Should it be -4? Is -33 plus 9 negative?
Yep. I meant to do that. And 7. You guys are catching me. That's good. And so you feel comfortable telling me when I've gone wrong. Yeah, I don't have an ego hang up. See? It's like, oh, I made a mistake. Yeah, there are people in this world that do have ego hang-ups. Like they're threatened. All right, we get negative infinity to -4. Do I put a parenthesis or a bracket on that? Bracket. Hopefully we'll be making those in March. Union with 7 to infinity. All right. Going to hit that last one. So I had the 6 and 4, right? You can tell me now. Greater than or equal to 108. We divide by 4 on both sides. We get the absolute value of 4x plus 7 greater than or equal to, what's 108 over 4? Is it 27? Yeah. I still got it. Oh, I'll still have it. And we solve them and graph them. Yeah, see, absolute value inequality is fun. Yeah, you'll definitely encounter one of these on your test and on your final exam. X will be greater than or equal to 5. Let's see, 4x will be less than or equal to -34. X will be less than or equal to -34 fourths. Well, that's -17 halves, I think. Yeah. So here's -17 halves, and here's 5. Greater than 5, less than or equal to -17 halves. So we go from negative infinity to -17 halves. Am I putting brackets or parentheses with my numbers? Brackets. Union with what? 5 to infinity. Awesome. So that, my friends, is how we solve absolute value functions. Now, I mean, I'm not going to stand up here and like model for you. I mean, if I did, well, couldn't get any better. I mean, so let's say you're comparing 2 parking plans for leased parking in a building downtown. Yeah, you've probably never heard of paying outrageous parking fees. You know, I grew up in Pittsburgh, where they compete with the borough of Manhattan for the highest parking tax in the country. It's either between the city of Pittsburgh or borough of Manhattan. I kid you not. I mean, borough of Manhattan, I could understand, but City of Pittsburgh. So Plan A has a monthly fee of $250 and an hourly fee of $10. Plan B is a monthly fee of $500, but your hourly fee is only $5. So if we let X be the number of hours you park, now there is a problem just like this on your test, but instead I've came up with an even more BS. Well, this is BS to you because you don't live, we're not in Pittsburgh or New York. If we were, this would really resonate. Yeah, that's why, like, my dad drove me to and from school every day, because parking costs, like, a lot of money in the city of Pittsburgh. But for the problem on the test, we put a toll on Interstate 40. That's illegal, but, can't do it anyway. All right, so express the cost of Plan A as a function of the number of hours parked. So Plan A has a monthly fee of $250 and an hourly fee of $10. So we call this, f of x. How would we write that in terms of x? 10x plus 250. Oh, I know, if I remember my wife got me tickets to a Steeler game one Christmas, and, well, you couldn't even get parking in the stadium lots. It's all reserved. People selling those parking permits for $100 a game. Now, G, the cost of Plan B, what's that going to be? Correct, 5x plus 500. So, for how many hours of parking would both be the same? Well, basically, you just set these equal to each other and solve. So yeah, we get a simple linear equation out of the deal. So we'll take away 5x from both sides. 5x plus 250 equals 500. 5x equals 250, yeah. And x is 50 hours. So that's where both parking plans cost you the same amount of money. In other words, a lot. All right, a cruise ship carries 10,000 passengers per month at a cost of $500 per person. I love going on cruises. Any of you ever been on a cruise? Try it sometime. It's a lot of fun. It was funny, my wife and I went on a cruise for our honeymoon, and we cruised down to New York. And I'll tell you, people that we met were like, you guys sound weird, because almost everybody on the ship was from New York or New Jersey. My wife has a bit of a southern accent. They're like, you're not from here, are you? Like, what's here? Like, oh, Long Island? Like, no, Virginia. So number of passengers, so basically we get 10,000 passengers, and the ticket price is X. So basically, so for every additional $1 in cost, the number of passengers would decrease by 800. So we're going to lose, basically, x minus 500 is our increase in price. Now, I'm not going to give you one like this on a test, so don't freak out here. I mean, I think I've told you plain as day what to expect. I hope. So all we got to do is simplify this. Minus 800x, 800 times 500 is 40,000. No, 400,000. So 410,000 minus 800x. So yeah, like if the ticket price, so the base price is 500, well, of course that's not really how it works. Our cruise is a lot more. I mean, but you do get a lot out of it. It's a lot of fun. And express monthly revenue. So basically, if X is the ticket price, X times number of tickets sold is your revenue equation. So we get 410,000x minus 800x squared. So that's not too bad. We're going to see some other types of problems. All right, so a machine is going to produce open boxes using rectangular sheets of metal measuring 16 by 10. So you're probably thinking, whoa, what the heckaroonie does that mean? So this is a 16 by 10, even though it's definitely not to scale. And what happens is we cut a square out of each size, out of each corner. And then what happens is we fold them up. And yeah, it becomes an open box. So basically what happens is, this is a horrible, crappy drawing, but we get 16 minus 2x for this, and 10 minus 2x for the width. Now the height is simply x. So basically the volume, as you should know, is length times width times height. So it would be 10 minus 2x times 16 minus 2x times x. We're not going to worry about expanding that, but but this is how it works. I remember when I was in, what we would do with this, if this were a higher level course, we would actually want to figure this out and optimize it. But the problem is we don't have a surefire way of doing that. Well, we can if we use the calculator, but we're not going to worry about that. Now the domain, I'm just going to kind of give that to you. X has to be between 0 and 5. That's basically what it has to be. What we would, what would happen if this were calculus? You would figure out the polynomial, take the derivative, and set it equal to 0, and that gives you the x value that you need. But that's a third degree. It's not going to work that way. Now, one like this this is kind of a what I like to call a teaser type question. You have 400 feet of fencing to enclose a rectangular garden. So what happens here is 400 feet of fencing. And that should be perfectly rectangular. Now we can call this W or L. Now, but here's the thing. What we would do here, we know 2W plus 2L definitely equals 400. So what you would end up having to do is solve for W or L. Now, this is as far as we're going to be going with this. We're not going to actually be optimizing this until Unit 2. This is kind of a teaser to get you to, we'll be able to actually optimize this by hand. No, that would be Unit 3, I'm sorry, yeah. Not even in this unit. So if we solve this for W or L, W would just equal 200 minus L. Now, area is length times width. We have a length times a width, which is 200 minus L. Basically, this becomes 200L minus L squared. Now, what we will be doing in unit number 3 is optimizing this. But I just wanted to kind of show you how this can be modeled. Now, a particular question I enjoy is one like this, an investment problem. So what's going to happen here, and you're going to see one like this on a test, where you will get a certain amount of money, and you'll place it into 2 different investments. Now you're probably thinking, wouldn't I just put all of it in a higher interest one? I should actually write the problem so that it says someone has put them into these accounts for you. Investing money, all this talk, people keep, in fact, I got a solicitation over the email today saying, Mr. Jarrett, I'm with this life, this insurance and investment company. We think you should be investing more towards your retirement. And they're telling me, like, if I take an extra $100 a month, and if it has a 10%, if it has a 10% rate of return, I can live very comfortably. But I'm thinking, of course, they put the disclaimer, not a guarantee that it'll happen. I could lose everything. In other words, I'm just going to keep working. I mean, unless I can't. So, if we so basically, this is simple interest. Now, you should be familiar with how simple interest is calculated. Basically, simple interest, you would take 6% and multiply it by whatever you invest, and that's, we're not getting into any of this fancy stuff with compounding interest. It's just simple interest. The thing is, too, if your investments do gain money, you have to pay taxes on that. So, let's say we let X be the amount we invested at 6%. Now, in terms of X, so basically, this is the amount invested, and 0.06X is the interest. Now, in terms of X, how much, what would that be for the amount invested at 8%? So let's say this. Let's say you have $50,000 and 20% of it, I mean 20,000 of it goes to the 6% account. 20,000 goes to that. How much is in the? How much would go in the other account? All right, $20,000 goes in one account. You have 50,000 altogether. What would you? How much would be going in the other account? 30,000. Of course, if someone gave me $50,000, I would just pay off. I would pay off my car, my wife's car, buy me a new one. So basically, to get the amount we invested 8%, we would subtract X from 50,000. So basically, 0.08 times 50,000 minus X is the interest from that. So altogether, 0.06X plus 0.08 times 50,000 minus X, you get $3,560. You got a nice simple equation to solve. Do it. So we got a nice equation here. So 0.06x, 0.08 times 50,000 is 4,000 minus 0.08x equals 3,560. So negative 0.02x plus 4,000 equals 3,560. We take 4,000 away from that. We get negative 0.02x equaling negative 440. We divide by negative 0.02, and we get x equal to $22,000 at 6%. Now, $22,000 at 6%. So, how much did we invest in the 8% account? 28,000. At 8%. Now, here's a way to check that you've gotten this all right. You take 22,000 times 0.06 plus 28,000 times 0.08. Simple interest. What's it going to be? $3,560. Pretty simple, huh? All right, so yeah, you will encounter one of these stock problems on your test. All right, I'm going to let you try this next one. All right, so you're getting $20,000 to invest. So X is the amount you invest at 20%. So that means the interest is 0.20x, or 0.2 times x. Yeah, oh, yeah, something paying 20%. Yeah, I'll believe that. You can pay 20%. Yeah, that's basically loan sharking. So 20,000 minus x is the amount at the 6%. However, the interest is technically negative. So basically, you have 0.20x minus 0.06 times 20,000 minus x equal to $2,440. And yeah. So 0.20x minus 1,200 minus plus 0.06x equals 2,440. 0.26x minus 1,200 is going to equal $2,440. 0.26x will equal $3,640. We divide out by 0.26, and we get $14,000 at the 20%. Now that means we invested $6,000 in the 6% account. Now, the one that is going to be on your test, both accounts are going to make you money. Maybe I could make you complacent here and think, oh, investing is the best thing, but my experience, no. All right, I'm going to let you try this next one. All right, so for this one, obviously, X is going to be what we invested, the amount at 8%. 65,000 minus X is what we invested at 12%. Yeah, getting a 12% return, that'll be the day. Since my wife and I moved to North Carolina, I get a North Carolina State Retirement Fund, and I've been checking it to see how it's been doing, and it's earned actually in the last year, the interest, it's been about 4% return, but prior, it was about 2%. So yeah, 0.08x plus 0.12 times 65,000 minus x equals $6,892. So we get 0.08x plus 7,800 minus 0.12x equal to 6,892. Negative 0.04x will equal negative $908. And that's going to be $22,700 at 8%. And the other thing is, whenever you see a problem like this on your test, yeah, you're obviously going to have more in the other. I am going to give you that. I'm going to put more in the other account for you. But in reality, I would put all 65,000 in the 12% account. You know why? Because you want more money. So 42,300 came up at 12%. All right, so for this last one here, this time I'm giving you $80,000. That's a lot of money to give you. What can you do with $80,000? So, X is going to be the amount at 8.4%. 80,000 minus X is the amount at 6.2%. Now, altogether, you earn $6,023.70. Yeah, 70 cents, can't complain about that, can. You can't even buy a Coke for that. Now, you can actually rearrange these. You could have done, X is the amount at 6.2%. It really doesn't make a difference. So basically, for this side, we get 0.022x plus 4,960 equal to 6,023 and 70. And 0.022x is going to be 1063.70. And X is going to be $48,350 at 8.4%. Now, in other words, obviously that's more than half. Now, if you got, so I will tell you this, on your test question, yeah, you invest more at the higher rate. And 31,650 was put into the lower yielding account. All right. So for Unit 2, there are videos on Moodle, video on 1.2 and then 1.3 material. What I'm actually going to do before the end of today, I'm actually going to combine Unit 1 and 2 into one unit on Moodle. So, we're just going to, so basically, you should see these on Moodle, which go to YouTube. 1.2 and 1.3. I am going to go over just a couple of things from here. But I do want to hit a few important things. So a function is a special type of relation in which each input or member of the domain has one distinct output. All relations are considered relations, but some may be considered functions.
We don't have this.
I didn't hand this out to you? I could have. Okay, you know what then? I handed out preliminary one. So, here's what I'm going to do then. We're going to do a couple more examples from previous one. I'm actually going to, all right, this put us in a bit of a, well, not so much of a jam, but Unit 2, yeah, the blank notes are on there. There's an open computer lab. It should be open. You can print them out. I'm actually going to go to my office right after this class and print them out if you want to get a copy. I'll do it that way. So, in that case, then, we'll round out our day and end with let's end with a couple of problems for fun. Let's see. Yeah, so what I'll do is immediately after class, I'll go up to my office and print them out. My office is in 321 Dogwood. Now, you can print these out, print out Unit 2 on your own if you desire. But, I will print them out. All right, so let's do it. What's the first step going to be? We're going to subtract x as well as 11. So you'll have 2x minus 5 equal to the square root of 4x minus 7. Little FYI, the problem that is going to be on your test, the other side will, the non-radical side will have like x plus or minus something. Because what will happen here is we need to do what to both sides now? We're going to square both sides. So basically, 2x minus 5 times itself will equal to 4x minus 7. We'll get 4x squared minus 20x plus 25 equal to 4x minus 7. Then we'll take away 4x and add 7 to both sides. So 4x squared minus 24x plus 32 is going to equal 0. Now, conventional wisdom says, you could just plug this into the quadratic formula or whatever, but I could divide the whole thing by, we can divide out the whole thing by 4. And both sides. So you have x squared minus 6x plus 8 equaling 0. So then that'll factor into x minus 4 and x minus 2 equaling 0. So basically x will equal 4, x will also equal 2. So what will happen now is we need to check each of these. So remember, the original equation was 3x plus 6 equal to x plus 11 plus square root of 4x minus 7. So we need to check each of these. So 3 times 4 plus 6 equals 4 plus 11 plus the square root of 9. Let's see, this is 18 equals 4 plus 11 plus 3. That works. For this, 3 times 2 plus 6 equals 2 plus 11 plus the square root of 1. 12 will equal 2 plus 11 plus 1. No. So we would call that extraneous. All right, so we'll go ahead and stop it here. So thank you, Haley and Hayden. Talk about this. So basically, we're going to look at what a function is. Now, before that, I want to talk just quickly about relations. A relation is a mapping or pairing of input values with output values. The set of input values is called your domain, and the set of output values is called the range. And other names for the domain and Okay, folks, welcome to another one of our many videos that you're going to be watching in this course. So this is going to be on sections 1.2 and 1.3 for guided notes of basic functions and graphs. If you need to find out where we are in the notes, this is on page 41. So what we need to do here is we're actually going to look at what a function is exactly. First, we need to look at a relation. We need to crawl before we can walk here. A relation is a mapping or pairing of input values with output values. The input values is called your domain, and the output values is called the range. Other names for the domain and range respectively are x and y, independent and dependent variables, explanatory and response variables, and input and output. So for this, relations can be expressed by using mapping diagrams, graphs, tables, equations, and vertical descriptions, as well as ordered pairs. So there is a special type of relation that exists where each input or member of the domain has only one distinct output. This is called a function. So all relations are relations, but not all are going to be functions. So for this set here, I have a domain. You know, the domain is the set of the x values. It always helps to put them in order, 1, 2, 4, and 5. The range is going to be 3, 5, and 9. So what you notice here is, yeah, we do have a range value that repeats, but since each member of the domain only maps to one member of the range, this is going to be a function, but it would not be one-to-one, but we're not really worried so much about that. Now, for a mapping, I'm just going to give you an example of a mapping here, like 1, 2, and 3, and then 4 and 5. So basically, you could write this as ordered pairs, 1, 4, 1, 5, and then 3, 5. Now, this is not going to be a function, and the reason that is because this input of 1 maps to 2 different outputs. So this is not a function, and we would always say y is or is not a function of x. It's never x is a function of y, well, not at this level. So we could also say y is not a function of x. So if we look at a graphical representation, with some points here, let's see, that's going to be at -7, -3.
Then we'll have one at 4, negative 4, negative 3. I mean, negative 4, positive 3, rather. One at 2, 6. And another at 2, negative 1. And lastly, one at 6, 4. So, the domain values are all the x values, which are negative 7, negative 4, 2, and 6. The range values are going to be negative 3, negative 1, 4, and 6. And if you notice, the input of 2 maps to 2 different outputs, so this is not a function as well. So, another way to determine whether a relation is a function is to draw a vertical line. If any vertical line passes through more than one point at any part of the relation, whether you have points or it's a continuous representation, we'll talk about that shortly, it either fails or passes the vertical line test. So we only did one graphical one. We already discussed that this was not a function, and was a very bad vertical line. This vertical line goes through more than one point. So what happens now is it's just further evidence that it's not a function. So, not bad. So, now if a function or relation seems to be connected in a way, we would be calling that a continuous relation or function, and that's mainly what we're going to be studying here. And any polynomial or linear function is going to be continuous. Otherwise, it would be discrete. Not discrete as in, keeping it discrete. This is discrete. Now, we actually work with what are called discrete probability distributions in statistics. This one is continuous. So, what happens here now is we're going to look at a little function notation. Now, f of x does not mean you are multiplying f and x together. Now, linear functions of the form y equals mx plus b can be written as f of x equals mx plus b. Again, this is read as f of x, not f times x. And f of x and y are basically interchangeable with each other. So, let's say we were to let f of x equal to 3x squared plus 2x minus 8. So if we want to determine a couple of things, for example, f of 3, what happens is you replace all x's with 3's, 3 times 3 squared plus 2 times 3 minus 8, and I'm not going to make you do that in the I'm not going to make you write out everything. And what this is going to equal is 25. So 325, x is the input, f of x or y would be the output. Now, if this were on a graph, 325 would be a point on this graph. Now, if we try f of 4/3, actually, I'm going to just do -2 instead. It'll be 3 times -2 quantity squared plus 2 times -2 minus 8. And when I enter this in my calculator, by the way, you should have a calculator, this is going to be 0. So the point that corresponds to this would be -2, 0. And we're going to see this in just a little while. Going to bring everything together. F of 4/3, yeah, I chose a fraction, and you're probably thinking, my God. Well, you can enter that 4/3 into the calculator as a fraction. You were shown in class how to do that. 3 times 4/3 squared plus 2 times 4/3 minus 8. This is going to be 0 as well. So the point for this is at 4/3, 0. Now, of course, you don't have to write out the point each and every time. I'm doing that just to give you an idea here. That's going to actually change now that we have a different input that is non-numerical, f of a. So since f of x is 3x squared plus 2x minus 8, basically all you have to do is replace the x with a. So it'll be 3a squared plus 2a minus 8, and that's it. So basically for f of x minus 3, what we're doing here is we're going to replace any and all x's with x minus 3. So you have 3 times x minus 3 quantity squared plus 2 times x minus 3 minus 8. Now, this is definitely going to be very helpful to you when we get into compositions of functions. What you would have to do is multiply that x minus 3, FOIL that out. I'm going to kind of cut some corners here. X squared minus 6x plus 9 plus 2x minus 6 minus 8. And we get 3x squared minus 18x plus 27 plus 2x minus 14. Whoops. That was an error on my end here, obviously. And if we want to, first off, I'm going to kind of make that a little smaller here real quick. Take just a second. And all we're going to do is combine any and all like terms. So, 3x squared minus 16x plus 13 is going to be the final answer. So that's the answer I would be looking for. You don't need to solve that equation or anything of that nature. Now, f of negative x, what happens here is we replace all x's with negative x. Now, when you square negative, you know it's going to be positive. So what happens here is negative x quantity squared is just positive x squared. Negative x times 2 is negative 2x, and then minus the 8. So that's how we do that. That's how we deal function notation. Now, if we look at these next couple of problems, we're going to determine whether each equation defines y as a function of x. I'm never going to say whether it defines it as, x is a function of y, because I've never, maybe in abstract algebra or something like that, but not here. So what we can do is solve this for y. 5y will equal 10 minus x to the third. Y will equal 10 minus x to the third over 5. Now, if you were to graph this, this would pass the vertical line test. So here's what will happen. Now, I actually don't have the calculator on this thing, so I'm going to actually add it later after the video. You'll see it in the notes that are on Moodle. So for this one, 5y squared will equal 15 minus 3x squared. We divide out everything by 5, and we'll have y squared equal to 3 minus 3/5 x squared. Now, since this is y squared, what happens is we take the square root of both sides, and you'll have y equal to plus or minus the square root of 3 minus 3/5 x squared. And what happens here is you'll be graphing two different functions. This will fail the vertical line test. Now, for this third example, 3x squared minus 6y squared equal to 18. Actually, I'm going to do something kind of cool here. Give me a second. Okay, so yeah, I was able to actually upload this. See, this passes the vertical line test. This fails the vertical line test. Now, if I solve this for y, negative 6y squared will equal 18 minus 3x. We divide out everything by negative 6. Y squared will equal negative 3 plus 1/2 x. So we take the square root. Y will equal plus or minus the square root of negative 3 plus 1/2 x. Now, since y does not equal one thing, instead it equals to a plus and minus of something, it's not going to work. So what we see here, obviously, is this is going to fail the vertical line test. Now for this one, you have negative 7y equal to 21 minus 3x. dividing out by -7, you would have y equal to 3/7 x minus 3. And if I were to graph that on my calculator and display that, we're going to see what happens. So for this last one here, yeah, this one passes the vertical line test because it's only one and it's y equals. So this one is a yes, and the first one was a yes. These other two were NOs for no's. Now, so what we have to do here is, if we were to graph f of x equal to 3x and then 3x plus 4, what happens is we fill in the values, and we did this here, 7 and then 10. Now, if you notice, the slope it goes up by 3, which happens to correspond to our slope. Now, if we were to graph 3x and 3x plus 4, that's up 3 and over 1, and you just draw the line. Very crappy line, I know, but that's how it's going to work. And 3x, and these lines are going to be parallel. 3x plus 4 is simply shifted up by 4. So that's how that's going to work. All right, so moving along here now, determining domain and range from graphs. Now, what you do here is, we'll use interval notation here because all of our functions are going to be. So if you look at the x value for the domain, it's going to go from -2 all the way to 8. Now, the -2 is not included, so that's going to be a parenthesis, but the 8 will be a bracket. And the range is going to be from -7 to +3. Now, generally for something like this, this is a linear function. It's not going to just stop. What's going to have is it's just going to go forever. Now for this one, if you notice, we have arrows that point downward here, which basically means it's going to go on forever. So the domain is going to be positive to negative infinity, or all reals. Now the problem is, it's not a problem. The range, see, the highest y value is going to be at 5. This is a quadratic equation. We're actually going to learn how to do domain and range of these things by the end of this course. The range, now this is in interval notation, but y is less than or equal to 5. But in interval notation, it will go from -infinity to 5, like this. And the 5 will be included. Now, for this, I didn't put circles here. So we can just assume that these are included. The domain is going to be from -4 to 2. However, it's going to also be unionized with 5 to 7. Because that indicates that there is a gap, and this is what we would consider a discontinuity. The range will go from 3 to 5, and even though it goes downward, it doesn't matter. It goes from 3 to 5 and 6 to 9. So that's going to be the range of this graph. Now, when we found out f of 4/3 and f of -2, they were both 0. So what happens here is we can plot those here. And if we go diddy-bop back up here a little bit, f of 3, it would go through 325, which is way off the charts. Now, I'm going to formalize this at a little bit later here, but when x is 0, f of 0 is simply going to be 3 times 0 squared plus 2 times 0 minus 8. So 0, -8. And that is going to be known as the y-intercept. So that's what we're going to get. And if you were to graph this on your calculator, it'll look something like this. You could probably get a much better graph if you used your calculator, but we're just going to accept this for now. So the intercepts, so here we'll have two x-intercepts. X-intercepts at, we could say they're at -3, 0, or x equal to -3, 1, 2, 3, 4, 5, 6, 7, and at 7, 0, or x equal to 7. You will never, ever want to say something like -3, 7, because that is implying that that's an ordered pair. Now, x-intercepts are where it touches the x-axis. Oh, all right, we're back. Sorry about that. So the x-intercept is where it crosses the x-axis. The y-intercept is going to be at 0, -3. So you could say the y-intercept is there. Now for this one, we're going to have two x-intercepts, one at -1 and at -5. You can write these intercepts either as ordered pairs or just x equal to -1 and x equal to -5. Those are your x-intercepts. And for this one here, we're going to have y equal to -5 is going to be your y-intercept. We're actually going to learn a little bit later on in the course how to calculate these intercepts even without graphing. So that's going to be it for this video. I'm going to post one for 1.3 very soon. Okay, welcome back folks to another one of these videos here. This one is going to be on section 1.3, more on functions and their graphs. So what we're going to be focusing on here is functions with interval, doing intervals of increase and decrease. We've already done domain and range. Now, what we have to do, for quadratic and absolute value functions, there's only going to be one interval of increase and one of decrease. Now, in order to read intervals of increase and decrease, what you need to do is read the function left to right as you would a book. So it's increasing when the function rises, decreasing when the function falls, and it's constant whenever it remains the same. Now, quadratic and absolute value functions, there's only one minimum or maximum point. With higher degree polynomials, we're going to have more of those, and we'll have to differentiate somewhat between absolute minimum and maximum and local min-max. Another word for that would be relative min or max. Now, a graph might not even have an absolute max or min depending on the equation. Eventually, you're going to be able to figure these out straight from the equation. So in the first two units, we're only going to be working primarily with absolute value and quadratic functions. Unit 2, we're going to learn a lot about transformations and stuff like that. Unit 3 is primarily quadratic. When we get into polynomials, we're going to be using the calculator a lot to figure these things out. So a maximum or minimum is an extreme point. It can be either absolute or relative. Now, since polynomials could have more than one extreme point, there might be more than one interval of increase or decrease. So what you need to do is put that union sign between them and remember that they are most certainly in terms of x. Domain of polynomials is always going to be all reals. Range is going to depend on any absolute extreme points and the end behavior. Now, it may not be the same direction on both sides depending on the degree. We're going to get to that. That's more unit 4. So we've got a little ways before we do that. Now, once you find your points, you can get this from your calculator, make a rough sketch of the graph. You would want to zoom in and out. It's actually better to change your y min and y max values. instead of doing zoom in and zoom out. And again, we're going to see this a lot more in detail when we get into the polynomial unit. So here, for each of the functions, state the intervals of increase, decrease, and constant. So basically what happens here is this is a maximum, and for that matter, it is actually the absolute max, and it is located at -3, 4. We call it the absolute maximum because it is the highest point that is on this graph. Now for this one, this is a minimum, and it's located at 1, -1. For this particular minimum, this is what we would call a relative or local. And for this one, it's not really a min or a max point, but it does change some things here. Now, it's going to increase. Now remember, you read from left to right. So starting here, we see, even though the function is pointing down, remember, read left to right. So it's increasing all the way from -infinity, and that point of increase stops where x is -3. Remember, you use the x value, not the y value. And we're using parentheses for these because these points are technically not included. It's now going to decrease from -3 to 1. Now if we go from 1 to 3, this point is 3, 3 right here, it is increasing, so we have another interval of increase from 1 to 3. And then from 3 on, it's constant. So where x is 3 all the way forever, from 3 to infinity. So these are the intervals. Now, if you could easily figure out the domain. Now, the domain for this is going to be all reals. So you could say negative to positive infinity. And what you would do for the range, you see that we have an absolute maximum point right here at -3, 4. Now remember, range is written in terms of y. So that is the highest value of y. So go from -infinity all the way up to 4. So that's what we get with this one. So for this particular function, we are increasing. This here is a local or relative max. So it's going to be increasing from -infinity all the way up to -6. From -6 down to here, this is, it's going to be decreasing. This is a relative min, and the reason it's not the absolute min, even though it appears to be, this function is just going on forever. You see the arrow, you just assume that behavior will continue. But it's decreasing from -6 to -4. Now, it'll be increasing all the way again from -4, where x is -4, all the way to where x is 6. Oh, that's not increasing. I mean, that's not decreasing, that is increasing. So from -4 to 6. And then from, this is the absolute max, because there is no point higher. So it's going to go from, decreasing, it'll go from 6 to infinity. The domain, there's no constant. Domain is always, going to be all reals, and the range, since the highest value is now at 7, -infinity to +7. So there's your range. Now, to determine whether a function is odd or even, here's what happens. If you replace x with -x and you get the same exact function as before, for what I mean by that is f of -x will equal f of x, it's going to be an even function and have symmetry about the y-axis. Now, if for a function f of negative x equals negative f of x, you get the exact same opposite as before. That function is going to be odd and be symmetric about the origin. Now, why couldn't a function have symmetry about the x-axis? Well, let's just draw something here real quick. Here's the x-axis. And if I were to draw a function that was symmetric about the x-axis, it would look something like this. And by order of the vertical line test, this is not even a function. So that's how that will work. So what I'm going to do here is, we're going to determine whether it's odd, even, or neither. So we're going to replace the x with negative x in each of these. F of negative x will have 3 times negative x squared minus 5. Well, if you remember, when you square negative, it becomes positive. So 3x squared minus 5. There is no change. Hence, the symmetry for this is even. I mean, it's an even function, and it is symmetric about the y-axis. And I'm going to put a graph on here in just a second to show you. All right, so, and as you can tell, these functions here, yeah, this is symmetric about the y-axis, and you see the symmetry, so symmetry about the y-axis. Now, for this one, we'll take g of negative x, and we'll get 8 times negative x to the third plus 5 times negative x, negative 8x to the third minus 5x. This is exactly the opposite. So this is what we would call odd, and this is symmetric about the origin. So for this third one, h of x equal to 4x to the third plus 12, h of negative x is going to be 4 times negative x to the third plus 12, which is negative 4x to the third plus 12. It's not the exact opposite, nor is it the same, so it is neither. Now, it may be symmetric about something other than the y-axis or the origin, but we're not touching that here. You won't even touch that until a much later course. So, that's how we do odd, even, or neither. Now, piecewise functions. So, what is a piecewise function? Well, a piecewise function is a function that is graphed in pieces. Each piece has its own particular domain. And there's multiple ways to handle these types of problems. Now, one way I'm going to do this, method 1 would be graph and erase. And what I mean by that here is f of x equals x minus 3, and see, it is valid when x is less than or equal to negative 3. Now, I'm going to draw that in red. So x minus 3, if you remember how to graph a linear equation, it starts here at negative 3. You go up 1 and over 1. That is your slope. And you can do it in the opposite pattern here. And what you'll see here is, you graph this function, and it looks just like this. Now, here's the thing. It is only valid when x is less than or equal to negative 3. So, less than or equal to negative 3 is where, this is where it's going to be. It's only valid to the left, so then what you do is you erase everything that's to the right of it. And that's what that's going to be. Now, I'm going to do this one in blue, x plus 4, and we'll have, it'll go up 1, or down 1, or whatever you want to do. And hopefully you get the idea that this is what it will look like. Now, since it's valid only when x is less than, greater than negative 3, here's the thing, where x is negative 3, but the other key to that is actually not going to be valid there. So what you have to do is put a open dot there. If that were a closed circle, this would be not a function. So, yeah, method 1, graphing and erasing. Now, method 2, plotting points. So, since we're dealing just with linear functions here, you know, it's 2 points to make a line. So, part 1, x minus 3, actually, I'm going to rewrite that. So, the first one is x minus 3, and that is where x is less than or equal to negative 3. So, find f of negative 3 and f of anything below negative 3. So f of negative 3 is basically negative 3 minus 3 for negative 6. So basically, it'll be at negative 3, negative 6. And we can plot that point right here. And see, it's already how it's on there. Anywhere to the left of negative 3, or, you know, to the left. So I'll try f of negative 5. F of negative 5 would be negative 5 minus 3 for negative 8. So the corresponding point is negative 5, negative 8. And when you see that, you know, we draw that, now we have 2 points, and yeah, and that's how that'll work. So we'll graph the other part doing this, you know, x plus 4, and that is where x is greater than negative 3. So f of negative 3, even though it is technically not valid there, that would be negative 3 plus 4 for positive 1. So negative 3, 1, but remember that it is open because of this. So that's how that will be. And I need to find something else to the right of that. I can just say f of 5. So that would be 5 plus 4. So the point would be 5, 9. So 5, 9, which is right here. And you see, here are the points. And that's how you graph a piecewise function. You can expect to see one of those on a lab assignment or a test. Who knows? All right, so for this last one, I actually think it might be easier to plot points for this. So, you know, we'll write this down here. There's 3 parts, 2x plus 5, where x is going to be less than negative 4. 3x plus 5, where x is between negative 4 included and 1 not included. And then 2x minus 1, where x is greater than or equal to 1. So what happens here is, let's see, 2x plus 5, I need to find the value at 2 points, so 1 will be at x equal to negative 4. Now keep in mind, that's going to be an open dot. So 2 times negative 4 plus 5, which will be negative 3. So negative 4, negative 3, and that's going to be an open dot. And I need somewhere to the left of that. I'll try negative 6. Yeah, 2 times negative 6 plus 5, which will be negative 7. So negative 6, negative 7, and that is going to be included. So remember, it's 2 points that form a line. It will look just like this. Now for this second one, this is actually a heck of a lot easier because we already know what our 2 endpoints are. So at x equal to negative 4, 3 times negative 4 plus 5, that will be negative 7. So negative 4, negative 7. And at x equal to 1, now here's the thing, keep in mind it has to be open there. So 3 times 1 plus 5 is 8. So at 1, 8, that will be an open dot. So you just connect those two. Whoop, not the best looking line here, but so that's how that part's going to be. Now 2x minus 1, where x is 1, 2 times 1 minus 1 is 1, so it's going to start at 1, 1, and it's going to be a closed dot because it is included here. I need something to the right of that. Let's say x equal to, I don't know, 4. 2 times 4 minus 1, which will be 7, so 4, 7, and it'll just continue from there. The other point you pick is just an arbitrary random point that you pick. That's all there is to it. So, and if you notice, the slope here is 2. The slope of this one is 3, and the slope of this first one is positive 2. That's why they call this a piecewise function, because it's graphed in pieces. All right, hope you enjoyed this video.